At present, we've now got a pretty well working inbox contract that exists inside of the Remix editor online. Now, it's fun to play around with the integrated JavaScript VM here in Remix. However, at some point in time, we're probably going to want to take this contract and actually deploy it out to either the test network or the main network. So we can actually use this contract with real projects that we want to build. So it's not enough just to edit this thing inside of Remix. We need to figure out how we can actually deploy the contract. So that's the real issue that we need to solve now. We've got Remix, here's our contract source, but how do we actually deploy it? For deployment, there's a variety of different options. Remember, at the core of whatever deployment process we end up using, it's always going to go through a very similar process. We're going to take our contract source. That source is going to be placed into the Solidity compiler. Just so you know, this compiler is running inside the Remix tool right now. The Solidity compiler is going to spit out both an ABI and the contract bytecode. And this bytecode right here is what actually ends up getting deployed to some network. So clearly, all right, Remix maybe does like half the job, but how do we actually get this code or that deployed or that bytecode over to our network that we want to deploy to? For that, there's a very common tool that you're going to see mentioned in a tremendous amount of documentation online and blog posts and all that kind of good stuff. And that tool is called Truffle. Truffle is kind of a one-stop shop for development of Ethereum contracts. This Truffle project, or the Truffle CLI, it's a command line tool that we can use to aid in contract creation, so like actually writing out source code, in doing some local testing, so programmatic automated testing to make sure that our contract behaves the way we want, and it is also useful for deployment as well. You're going to see a lot of mentions of Truffle as soon as you start working with any type of Ethereum project, and it's a very common tool to use on any professional project as well. Now, it sounds like I'm kind of talking very nicely about Truffle here, right? I'm saying, yeah, everybody uses this thing, and it does a lot of very helpful things for us. Well, there's just one little issue here. Just one little issue. Here's the thing about Truffle. Truffle is still undergoing rapid development. Some things about Truffle don't really work well. Like some functionality in this Truffle tool is a little bit rough around the edges. Other things don't work at all. So Truffle has some features that you would really expect it to have, but they don't actually work. They don't exist. They have not yet been implemented by the authors of the Truffle library. And above all, features inside of Truffle sometimes break. So maybe one day everything is working fine. You then update to the latest version of Truffle, and all of a sudden some feature of it is not working at all. The point I'm trying to make here is that all the technology that we are using around Ethereum, so not only Truffle, but also Remix and MetaMask and Web3, all these different libraries are still in a very constant state of flux. So if you are used to using software or third-party libraries like Node libraries or JavaScript libraries or gems, whatever dependencies you're used to using that might seem like they're really rock solid and very dependable for projects that you work on today, you really can't bring that same attitude over to the Ethereum world. The dependencies that we are using are going to break. Sometimes they don't function well, or they don't function at all. And that's just part of the very developing and active ecosystem around Ethereum. So what I'm really saying here is as we start looking at Truffle and a variety of other tools that we're going to use throughout this course, you really have to have some amount of patience. Please, I beg you, because some of these tools are really rough around the edges and they're just not going to work the way you expect. But hey, that's why we're here. That's why we're in a course trying to learn how this stuff works. So with all this in mind, with this knowledge that, hey, sometimes things don't work at all, from my perspective, trying to teach you this stuff, it seems like a very clear solution is to try to use as few of these tools as possible. So for this first project that you and I are going to put together, in order to deploy our inbox contract code right here to the actual Rinkeby network or to any network whatsoever, rather than using Truffle or any other fancy tools, you and I are going to put together a custom node project from scratch that's going to aid us in contract creation, in doing some local testing, and actually doing deployment to the Rinkeby network. So there are tools out there to automate this process and make it very easy to get set up and started. But I'm saying that, hey, sometimes they're not quite dependable. So I want you to understand what these tools are doing behind the scenes. So you and I are going to build our own custom boilerplate that is going to aid in all these common tasks. And we're going to set it up all manually so you have a great idea of what these tools are actually doing. It's really going to be a lot of fun, and it's going to give you a lot of insight into the purpose of Truffle and Web3 and all these other libraries. So with this in mind, let's continue in the next video, and we're going to start setting up this custom project that's going to help us run, test, and deploy our our Ethereum contracts. So quick break, and we'll start that in the next video. In the last video, we spoke about how we would create our own custom boilerplate project that's going to aid us in developing, testing, and deploying our contracts. Again, Remix is great, but it's really limited to the browser. Chances are you're going to eventually want to use your own code editor, and chances are you're going to eventually want to use version control, like say Git, to manage the contracts that you write. So although Remix is great, the fact that it only runs in the browser is a little bit of a constraint. So instead, we're going to make our own custom project. This custom project is going to have a couple of big issues that we're going to have to tackle tied to it. So I've laid out some of the big issues and possible solutions for each of them. The first thing that we need to be able to do inside of our boilerplate project that we're going to put together is to make sure that you and I can actually write some Solidity code that can then be accessed in some fashion from the JavaScript side of our project. Remember, everything we do in this course is going to be JavaScript themed. So I want to be able to write some JavaScript code to test my project, to deploy my contract, and to eventually work with my contract after it has been deployed. It's all JavaScript. However, we are writing Solidity contracts. In order to get a bridge between the Solidity side of our contract and then somehow interact with it from the JavaScript side, we're going to need to set up that Solidity compiler. And remember, we've been saying that the Solidity compiler spits out an ABI that we use to work with JavaScript and the actual bytecode, which is what gets deployed to the network. So we're going to make sure that the Solidity compiler spits out both those different pieces so we can both deploy our project and actually work with it from the JavaScript side. The next big challenge that we need to be aware of is the fact that so far we've had a fantastic testing tool in the form of Remix. So we've been writing some contract code. We could then deploy that contract to a local virtual network that's running inside of our browser, and then we can click buttons very easily to run some of the different functions that are tied to that contract. Now that's all great. That's a very manual testing process. It's very visual and it's pretty easy to get started with. But chances are, as we start to develop more complex contracts, we're going to eventually want to have some set of automated tests that will execute and make sure that our contract is working the way we expect. Remember, these contracts can control an amazing amount of real money, very, very real money. So we need to be 100% positive that before we deploy our contract, we have something that is working the way we expect. In order to set up a testing pipeline inside of our project, we're going to be making use of the Mocha test library. Mocha is a very generic and general testing library that gets used with all types of JavaScript projects. If you've never worked with Mocha before, don't sweat it. It's actually going to be a great experience that's going to teach us a lot about how to interact with Ethereum contracts from JavaScript code. So setting up this test runner right here to test our contract is really going to be a lot of very great and important experience that we gain in this course. Finally, our boilerplate project needs some way to take our compiled contract, so the actual bytecode, and deploy it to a public network. And that might be the main network, it might be Ropsten, it might be Rinkeby, just some public network. And we're going to set up our project to do that in an automated fashion. For this, we're going to create a little script that is going to both compile, so we're going to run the Solidity compiler, our contract, and then take that outputted bytecode and somehow deploy it to the network. Now this might sound like I'm just kind of restating the problem here. I'm not really giving us a very clear solution here, but trust me, when we get to this step, all things will be made clear, and we're going to have a very specific and well-tested solution for deploying our contract. So this is the goal. This is what we're going to tackle inside of our boilerplate project. Now for the very last step, before we get started, we're going to flip back over to our terminal, and we're going to generate a new project that we can work with. So I'm going to flip back over to my terminal over here. I'm going to create a new project directory, and that's where we're going to place all the code that's going to work with our contract, compile, deploy, all this stuff. So at my terminal, I'm going to make a new directory, and we'll call it, how about simply inbox? and then we'll change into inbox. And then finally, we will generate a new node project by running the command npm init. We'll see a couple pop-ups here asking us for some information. For right now, there's really not any extra information we need to enter, so I'm just going to hit enter a few times. And eventually we end up with something that says, is this okay? And we get kicked back to the command line. And now we should see a new package.json file inside this new directory. Great. So let's continue in the next video. We're going to start to install a couple of dependencies and also set up some pipeline to automatically compile our code. So I'll see you in just a minute. At the end of the last video, we generated a new package.json file inside of a new inbox project directory. You'll notice that I started up my code editor. I'm making use of Atom here. I encourage you to open up any editor that you want to use based on this inbox directory. Remember, you can use any editor you want here. There's no one editor that's better off for working with Solidity contracts just yet. So you can use VS Code, you can use WebStorm, whatever you want to use, it's completely up to you. In general, I recommend you use the same editor that you're used to for working with JavaScript projects already, because a lot of the stuff we do is going to be very closely coupled with JavaScript projects already. All right, now before we start just diving in here and writing any code, I want to give you a quick overview of some of the different project files and folders that we're going to create to organize our code. The first folder that we're going to create is called contracts. This contracts directory will contain the raw source code for each of the contracts that we end up building. Our current project is only going to have one contract, which is going to be referred to as inbox.sol. .sol means that this file right here is going to contain some Solidity code. If we had other contracts, we would also locate them inside the contracts directory. The next directory we're going to make is going to be called test. This is going to contain one file that's going to be testing the inbox contract using some Mocha code that you and I are going to write. The inbox test file right here is going to be where we spend the vast majority of time with this first project that we're working on. It's where we're going to learn how to interact with a contract using JavaScript code. Next, inside of our root project directory is the package.json file. Like any other JavaScript project that you might have worked on over time, the package.json file will behave in the same way. So we're going to create some number of scripts inside of it, and it's also going to record different dependencies that we install into our project. Next up is compile.js. This will be a small script file whose sole purpose will be to look inside that contracts directory and compile each of the Solidity contracts that exist inside of it. So this is going to be kind of a one-off project file or a one-off file that is used solely to compile our code. And then finally, we have deploy.js. This is also going to be a little script file whose sole purpose will be to take some compiled code and deploy it to an Ethereum network. And that might be the main network or Ropsten or Rinkeby or even a private local network as well. All right, so now we've got a little overview. Let's get started by creating this contracts directory and the inbox.sol file as well. So inside my code editor, I'm going to create a new folder called contracts. And then inside there, I'll make a inbox.sol file. Next, I'm going to flip back over to Remix, where I have all my inbox source code. Here it is right here. I'm going to copy all of it, and I'll flip back over and paste it in. You'll notice that when I paste my code in, I get some nice syntax highlighting on all the contract code. Chances are you might not have any syntax highlighting on by default. A lot of code editors presently do not ship with any understanding of what Solidity code looks like, and it doesn't really know how to properly highlight it. I've already taken the liberty of installing a small add-on inside my code editor that teaches Atom how to do syntax highlighting. In the next video, I'll put in the next lecture, I'll put some text and I'll link you to a couple of different plugins that you can use depending on your code editor to get some nice syntax highlighting like you see right here. So let's pause here. We'll continue in the next section. You can take a look at your specific code editor and download and install some syntax highlighting for it. Now, one quick thing I want to mention about syntax highlighting, it is not strictly required at all. The only thing that this plugin is doing for me inside of Atom is making the code look nicer. I don't get any autocomplete out of it or anything like that. So if you have a tough time installing one of these packages for syntax highlighting, don't sweat it, just move on, and please don't spend too much time trying to get the syntax highlighting to work. So let's pause right now, and we'll try to set up some highlighting in the next section. We've now got the contents of our contract all put together. Now thinking about our project itself, we're going to start working very quickly on the compile.js file. The reason we're going to go directly to the compile.js file is that both the deployment process and the testing process is going to expect that we have a compiled contract ready to go. So in order to do any testing or any deployment, we first have to solve this compilation step. To do the actual compilation step inside of our project, we're going to make use to the Solidity compiler. Remember, we're going to pass some contract source code into that compiler, and then that is going to spit out the ABI, which is our JavaScript interpretation layer of what the contract is, and also the contract bytecode, which is what we actually deploy off to the Ethereum network. To install the Solidity compiler, we're going to install a tiny little node module. Back at my terminal, I'm going to make sure that I'm inside of my project directory, and then I'm going to install the Solidity compiler as an npm package by running npm install --save solc. Solc is the actual Solidity compiler, and as you might guess, it stands for Solidity, that's the SOL part, compiler, that's the C. It's a pretty small module, so we'll just start the installation and then flip back over to our code editor. Inside of my root project directory, I'm going to create the compile.js file. So I'm going to make new file, compile.js. Now, actually making use of the Solidity compiler is pretty straightforward, but there's just one little hoop that we have to jump through. You might be thinking that to get access to this file, we could write some type of require statement. You might be thinking we could write something like require contracts inbox.sol. And that's not the case. This is bad right here. Remember, whenever we require a file into a node project, the node engine will attempt to execute that contents of the file as though it were JavaScript code. So if we attempt to require in the contract file, it's going to immediately throw an error saying, hey, this isn't JavaScript code that you're requiring. So rather than attempting to directly require in this file, we have to read the contents of the file off of our hard drive. To read the contents out, we're going to be making use of two separate built-in standard library modules. Let's require both these modules at the top, and then I'll tell you about exactly how we're going to use them. We're going to first require in path, and then we'll also require in fs. Again, these are standard modules, so we don't have to npm install them at the terminal. The path module is going to help us build a path, like a directory path, from the current compile.js file over to the inbox.sol file. The reason we're going to use the path module for this, rather than attempting to just write out the path directly, is that by using the path module, we are guaranteed to get cross-platform compatibility. In other words, if we try to run this compile script on either a Windows system or a Unix-based system, the path module will make sure that we always generate a valid path. So let's first start off by generating a path to the inbox.sol file. I'm going to say const inbox path, and we'll call path.resolve. And then we're going to pass in three portions of the path. The first portion is going to be underscore, underscore. So this is two separate underscores right here, dir name. Dir name is a constant that is defined by node, and it always gets set to the current working directory. So that will take you from your root directory or your home directory on your computer all the way to the inbox folder. Then the two separate second arguments that we're going to pass in here are going to be the contracts folder and the inbox.sol file. So we'll say contracts and inbox.sol. Okay, so again, this is going to generate a path that points directly to the inbox.sol file, and we're jumping through this hoop right here of using this function to make sure that it works on either Windows or Unix-based systems. Now that we've got our path, we can attempt to read in the contents of the file. So we're going to read in the raw source code from our contract. To do so, we'll create another temporary variable, and I'll call this one simply source. To read in the contents of the file, we're going to use the file system module. I'm going to say fs.readFileSync. I'll then pass in the inbox path, and then we have to specify what type of encoding is used for this file, or for the inbox.sol file. And for both you and me, it's going to be UTF-8 encoding. Okay, so now that we've got all of our source code from that contract file inside this source variable right here, we can now write the actual compile statement by using the Solidity compiler. We'll first start by requiring in the Solidity compiler at the top. So I'll say const solc is require solc, and then we can call solc.compile. We'll pass in our source code, and then we also have to specify the number of different contracts that we are attempting to compile. In this case, it's just one. And that's pretty much it. Now for right now, we're going to just console log the output of the compile statement, and that'll give us a better idea of what the compiler is doing. So let's just wrap that compile call in a console log, like so. All right, let's take a break here. We're going to come back in the next section and run this compile file and see exactly what the compiler is doing for us. So I'll see you in just a minute. In the last video, we finished up our compile.js file. Let's now run this at the terminal and see what happens. We should see a console log immediately appear on the screen, but I'm kind of curious what data the compiler is really returning for us. So back at my terminal, I'm going to make sure I'm inside of my inbox project directory, and then I'll run the command node compile.js, like so. The compiler usually takes a couple of seconds to warm up and actually compile our files, but after about 5 or 6 seconds or so, you should see a console log appear on the screen, like the one that I see. If we scroll up, you're going to see that there's a lot of data that just got console logged. So let's go up, 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 all the way to the top of the console log. All right, here we go. The return value from the compiler, whenever we call .compile, whenever we call the compile method right here, is always going to be an object. So here's that top level object. Inside that object, there is a contracts property that contains another object. This contracts object right here contains all the different contracts that were just compiled by our compiler. The Solidity compiler is built assuming that you might want to compile multiple contracts in one go. In our case, we have just one contract, just the inbox contract. But if we had other contracts that we passed in at the same time, we would also see key value pairs inside this object that match up with the other contracts that we attempted to compile. There's two properties on this object that represents the compiled inbox contract that we really care about. The first is right in front of us, bytecode. Bytecode right here is the actual bytecode that we are going to deploy to an Ethereum network. So yep, believe it or not, this series of numbers and letters represents the actual code of our contract that is going to be stored and executed on the blockchain. If we scroll down a little bit beneath that, you'll find another property called interface. Interface right here is our contract ABI. And remember, the ABI is essentially the communication layer between the Solidity world and the JavaScript world. Now, if you look at the actual ABI or the actual interface itself, you might be a little bit disappointed. You'll notice that there's really not a lot of information in here. The ABI really just lists out all the different functions that exist on the contract, all the different functions that can be called. It also specifies how many arguments, what type of arguments, what return values, and what type of return values are handled with each of those functions. I know the text in here is kind of hard to read, but you can see, for example, maybe we could start right up here at the top. You might see something that says name, there it is, set message. So this is an entry for our set message function. The set message function requires one input, so here's inputs, that's called new message, and its type is supposed to be a string. So I know this is kind of hard to read, but you can kind of get a sense that the interface is specifying the different methods and their kind of format of inputs and outputs. If you want to, you can certainly look through some of the other properties on this object that got returned to us from the compiler. But again, the only two that we're going to be making use of are the bytecode property and that interface property. All right, now that we've got a better idea of what's going on inside the compiler output, we're going to go back over to our compile.js file, and we're going to remove our console log. So I'm just going to make sure I clean up the console log and the set of parentheses on the left and the right, like so. Now, of course, whenever we compile this file, we need to somehow make it available to other files inside of our project. So at this compile line right here, we're going to add a module.export statement in front of it. And that's going to make sure that we can simply require in the compile file and immediately get access to our compiled source code. So right before the solc.compile, I'm going to add on module.exports equals solc.compile, like so. So when we do this, we're now going to be exporting that big giant object that has the contracts property and then a list of all the contracts that were compiled. Now, because our project only has one contract that we're going to deal with, I think that maybe rather than returning the entire big nested object that comes back from the Solidity compiler, maybe we should really just be returning some details about the inbox contract. So I think that after calling solc.compile right here, we're then going to access the contracts property. And remember, on that contracts property, let's go look at it. So here's contracts. On the contracts property, we really only care about the key value pair of inbox right here. We really just care about this object because this is what contains the actual bytecode and interface. So we just made reference to contracts, and then on contracts, we'll further pull off the inbox property. And notice this is :inbox, not just inbox. So to get access to that, we can put our square braces, and then in a string, :capital I inbox. Cool. So now whenever we require in the compile.js file, we will get direct access to an object that contains just the bytecode property, which is our contract source, and the interface, which is our ABI. That's going to make it a lot easier when we go to deploy or test this contract in the future. We won't have to remember to destructure off contracts and inbox like so. All right, this is looking pretty good. Let's pause right here, and then in the next video, we're going to start wiring up our testing solution with Mocha to make sure that our contract is actually behaving the way we expect. So quick pause, and I'll see you in a minute. We've now got a pretty solid compile script put together. So this will take our raw contract code and spit out both the ABI and the bytecode for the contract. And that bytecode can be taken and deployed to some network. Now that we've got the deployment, or excuse me, the compilation put together, we can start thinking about deployment and testing of our contract. In this video, we're going to start working on the testing aspect of our project. Remember the goal behind testing. These contracts can work with a lot of money, so we need to make sure that they are working in the way that we design them. That's the entire goal of testing a contract. So let's talk about the way in which we're going to test this thing. First, just as a quick reminder, and I know I said this just 2 seconds ago, remember we take our contract, we put it into the compiler, and we get out the ABI and the bytecode. So you might be thinking, well, at what point in time are we testing something here? Like, are we testing the actual Solidity code? Are we testing the ABI or the bytecode? Well, in reality, we get to actually write some very functional tests. And when I say functional, I mean we're going to write some tests that can directly call different functions that exist inside of our contract. So they're going to be very effective tests that you and I write. So here's our testing setup. At the very top, we've got our Solidity compiler, which is going to spit out our bytecode and our ABI. You and I are going to take this bytecode and we're going to deploy our contract to a local test Ethereum network. This local test network right here is going to be running on our own personal laptop or desktop. We're going to generate a new local network solely for the purpose of deploying and testing our contract. This really shouldn't be that crazy. If you recall, whenever we use Remix, so here's Remix right here, whenever we deploy a contract, or I should say click Create right here, that deploys a test version of our contract to the local Ethereum network that is running inside of our browser. So this is something that we've essentially already been doing by using the tool Remix. Our local test network is going to be created by a library called Ganache. You'll notice I have labeled this as both Ganache and TestRPC. So just a little history lesson very quickly. This library, this local test network that we're going to use, was previously called TestRPC. So that's the old name of this library. More recently, TestRPC was renamed as Ganache, or Ganache CLI. You will see a lot of documentation and a lot of blog posts that refer to TestRPC. So just remember, anytime you see TestRPC, that is the old name. It is now more recently called Ganache. All right, so we're going to take our bytecode from our contract and we're going to deploy it to this local test network. Then on the other side over here, we're going to take that JavaScript interface, or our ABI, and we're going to feed that into Web3. Remember, Web3 is a library that we use to get programmatic access to a deployed contract on the blockchain. So Web3 right here is kind of our portal into what is going on this local test network. We're going to be using Web3 quite a bit throughout this course, so this is going to be our first taste of it, and we'll be making use of it basically throughout the rest of the course as well. All right, so now that we've got a better idea of some of the very high-level architecture, let's pause here and continue in the next video where we're going to start the installation and setup of both Web3 and our Ganache local network. So I'll see you in just a minute. Let's now continue by doing a little bit of installation of Web3 and Ganache as well. I'm going to flip on over to my terminal where we're going to install those libraries. So I'm going to make sure I'm inside of my project directory of Inbox, and we're going to run npm install --save, and then we're going to install a couple of different libraries here. So first, we're going to get our testing framework of Mocha. We're going to install the Ganache-CLI library. So this is the actual test local Ethereum network that we're going to deploy our contract to. And then finally, we're also going to install Web3. Now I've got a lot of stuff to say about Web3. And some of it is good and some of it is bad. One of the bad things I have to say about Web3 is that it's going through a major version change and a major rewrite of the library itself right now. So we're going to install a very specific version of Web3 to make sure that you and I are going to be writing the same exact code. So we're going to write Web3 at 1.0.0-beta.26. And I'll zoom in just a little bit to make sure that's really nice and large. So make sure you have Web3 at 1.00 beta.26. All right, and we'll run that. The installation here is going to take just a minute. So while that's going, let's flip on over to our code editor. Now inside of my inbox directory, I'm going to make that new folder called test, which is going to hold all the different tests that we might write for our project. So I'll make a new folder. I'll call it test. And then inside of here, I'm going to make a file called inbox.test.js. So this is where we're going to write all of our code to write some assertions or make some assertions about our deployed contract. We're going to be writing a lot of code in this thing over time. Let's get started right now by importing one or two different libraries. At the top, we're going to import or require in the assert module. Assert is another standard library that is built into the Node.js runtime. Assert is used for making assertions about tests. So we might assert that some value is equal to another value. We'll get a lot of experience with assert very shortly, so we'll come back to that topic. The next thing we're going to require in is Ganache, or more specifically, the Ganache CLI. So we'll say const Ganache is required Ganache CLI like so. Again, this is going to serve as our local Ethereum test network. As soon as we start to actually make use of this thing, I think you'll have a better sense of what it's doing for us. So let's just kind of hold on to that front as well. And then finally, we're also going to require in Web3, like so. Now, really important, I want you to notice how assert and Ganache right here are lowercase, but Web3 is actually uppercase. Whenever we make use of Web3, we are always going to be requiring in or importing a constructor function. So this right here is a constructor. It is used to create instances of the Web3 library. By tradition, or by convention, I should say, whenever we are working with a constructor function, we always capitalize it. And so that's why we see capital WEB3 right here. It's really important to note because in the next line of code that we're going to talk about in just a moment, probably in the next video, we're going to create an instance of Web3. And by convention, we usually assign the instance to a variable that is lowercase Web3. So this is essentially our constructor function, or you can think of it as being our class. This is the actual instance of Web3 that you and I are going to work with. All right, let's pause right here. Let's take a look at our installation. Looks like everything is okay over here. So let's pause for just a moment. We'll come back in the next video and we'll talk about why we are going to create an instance of Web3 and exactly how Web3 works overall. So I'll catch you in a minute. In the last video, we installed Ganache CLI, Web3, and Mocha as well. Before we move on, I want to give you a little quick tip about the Web3 library. Now, this is probably one of the more important videos in the course, at least as far as things go from saving you time. So the real goal of this course, this video right now, is to save you time as you start doing your own research around building Ethereum projects in the future. So this is just a little tip, something I hope is going to save you some pain. So here's what's up. I want you to be aware of versioning issues around Web3. So this is the thing that's going to save you some time, just being aware of this issue. In the Ethereum world right now, Web3 is used as the absolute end-all solution for communicating between a JavaScript app and the Ethereum network. Remember, several times we've said that Web3 is kind of like our portal into the Ethereum world. It's how we get programmatic access to an Ethereum network. Now, the issue here is that there are two groups of versions of Web3 out in the wild right now. There's version 0.something. The most common version you'll see is 0.21 something. And then on the other side, more recently, version 1 has been released. Now, you and I just installed version 1, so we are working with the newer version of Web3. What I want you to be aware of is that at this point in time, the vast majority of documentation, the vast majority of Stack Overflow posts, the vast majority of blog posts out in the wild talking about Ethereum are all using the older version of Web3. This is kind of a big deal because the API, or the way that we work with both these libraries, is significantly different, significantly. In particular, the earlier version of Web3 had a little bit more primitive interface for working with the library. It had support only for callback functions for whenever we wanted to work with asynchronous calls. And unfortunately with Web3, just about everything we do is asynchronous in nature. So if you want to, say, get access to a contract, or call a function on a contract, or send money from one person to another, these are all asynchronous actions that we execute using Web3. And the only way to get some indication that our function call or our transfer of money or getting access to our contract has been completed successfully is by providing a callback function. In general, we do not like callback functions as developers. They are generally hard to keep organized in our code, and it's really easy to write some ugly looking spaghetti code that is difficult to understand when we're working with callbacks. So this earlier version of Web3 did not have support for promises or anything that could kind of easily make our code look nicer. This problem has been solved with version 1. So version 1 of Web3 does have support for promises and the much newer async await syntax. So with version 1, you and I get to write some very nice, pretty looking code, which is great. That's what we want to do. And that's why we're using the newer version of Web3. So again, as you start to do your own research, I just want you to be aware that you will see blog posts. You will see Stack Overflow posts and all these types of things that make use of this earlier version of Web3. But I really encourage you to get familiar with version 1 because of course we want to learn the newest version of these libraries. Okay, so that's just a real quick note on Web3. Just be aware that this is a problem, and sometimes you'll look at these documentation resources that use some older code, and we don't really like using that older version. There are, of course, other differences between these two libraries, just beyond the fact that one has callbacks and the other has promises, but those are more of the differences in how we call certain functions, and I bet you could guess that, yeah, hey, they're different, whatever. But the big difference I want you to be aware of is that this does not have support for callbacks, or this does not have support for promises over here. Okay, so now that you understand the difference and why we care about the new version, let's continue on, and we're going to start talking about what Web3 really does for us internally. So, quick break, and I'll see you in a minute. In this video, I'm going to start telling you a little bit more about Web3 and how it works internally. You'll recall that I just said that we spelt this variable right here specifically with a capital W because it was a constructor function. Whenever we make use of Web3, we have the constructor function, and we use this to make instances of the Web3 library. We can make multiple instances inside of one project. The purpose of each instance is to connect to a different Ethereum network. Now, it's relatively uncommon for us to want to access multiple networks from one application. So personally, I really expect that in general, you're only ever going to be working with one instance of Web3 at a time. With that in mind, let's take a look at a diagram that gives us a better idea of how Web3 is organized. So right here at the top, we have the Web3 constructor function. So this is what you and I just required into that inbox test file. We're going to use the constructor to make an instance of Web3. Whenever we make an instance of Web3, we have to immediately do some configuration of the new instance that we have created. And in particular, we have to set up something called a provider. A provider can be thought of as like a communication layer between the Web3 library and some specific Ethereum network. So the provider right here, this is a communication layer. Every provider that we ever make use of for connecting to different networks has an identical set of methods on it. These different methods allow the Web3 library to essentially send a request over to a local network and to receive a response to that request. You should really think of the provider right here as being like a telephone or a cell phone, and Web3 and Ganache as being like two people who are trying to communicate. So this might be me standing right here. Maybe I'm a copy of Web3. Maybe you are a copy of Ganache. Sorry that you had such a lot in life. And we might use this provider as a communication means to exchange messages with each other. Of course, Web3 is always going to be connecting to or talking to, communicating with some Ethereum network. So Web3 is always going to expect you to provide a provider. If you don't provide a provider, Web3 is going to complain and it's going to say, hey, I have no idea what network I'm supposed to be talking to here. Now, I specifically drew this kind of little notch in the diagram right here so that you can kind of understand that we're going to take this Web3 instance and we're going to kind of plug in a provider like so. In this case, the provider is coming from this local test network that you and I are putting together, but we could easily swap this provider right here out and replace it with some other provider that speaks to a different network. So these are exchangeable providers. But again, in general, you and I are only ever going to be working with one network at a time. All right, so now that we've got a better sense of what's going on in the provider, let's flip back over to our code and we're going to set up our local instance of Web3. So back inside my code editor, I'm going to create an instance of Web3 by saying lowercase Web3. So again, notice that the capitalization of the first letter indicates whether we are working with the constructor or the instance. So lowercase means instance. We'll then say new Web3. In this case, this is the constructor function, so we're using the capital here. And then to the constructor function, we're going to provide ganache.provider, like so. So this line of code right here is what creates an instance of Web3 and tells that instance to attempt to connect to this local test network that we are hosting on our machine solely for the purpose of running these tests. In the future, when we start to connect to other networks, like say the Rinkeby test network or the main network, we will replace this provider with a different provider that will link us up to those other networks that we want to access. So again, this first argument right here is going to change over time depending on what network we are attempting to connect to. All right, I know that was a lot of discussion for just one line of code, but this provider thing is going to really haunt us. That's really the best term I can come up with. The idea of a provider is going to haunt us over time, especially as we start using MetaMask to interact with our applications in the browser. So this topic is going to come back up in a really big way later on in the course. All right, let's pause right now. And in the next section, we're going to get a better sense of how we can use Ganache and Mocha to write tests around our contract. So I'll see you in a minute. As we said a couple videos ago, we're going to be testing our contract by using the Mocha testing framework. In this video, I'm going to give you a quick overview or refresher of Mocha and how it works. If you are already familiar with Mocha and you've already used it in the past, then feel free to pause this video right now and continue on to the next video. Because again, this is going to be mostly review if you've already used Mocha before. Okay, so if you're still here now, I'm going to assume that you want to go ahead and get a quick refresher or overview of Mocha. Mocha is a test running framework. We can use Mocha to test any type of JavaScript code that we want. So we can use it to test a front-end application, a back-end application, or even Ethereum code, which is what we are about to do right now. So it's a very general purpose testing framework. Being so general purpose, it has a very small set of functions that we need to understand. So it's pretty straightforward and easy to get started with. Let's take a look at the 3 functions that we need to understand to really make sure that we can work with Mocha. So we're going to take a look at a diagram here really quickly. All right, these are the 3 main functions that we need to be aware of: it, describe, and before each. We're going to talk about each of these functions, and then we're going to walk through a very small testing example to get a sense of how they all work. The first function that we need to be aware of is the it function, and it literally is called just it. The purpose of it is to run one individual assertion on something that we're trying to test. So this is really the unit of measurement for testing. It's the absolute core of testing something. I've been using the word assertion a little bit, by the way, and just to make sure it's clear, whenever I say assertion, I mean to say that we're going to take 2 values. One value that our code has produced, and then another value that we think should be equal to that variable. We'll then compare the 2 together and make sure that the value that our code produced is what we were expecting it to be. So we refer to that as an assertion. If the it statement is the core of any test, then describe is what we use to group certain functions together. We use describe to group together a collection of it functions. Describe is really just organizational in nature. Describe just helps us group together certain functions that are testing the same thing, so that when we go and look at those tests in the future, or when we look at the output of our testing report, we can understand that certain groups of our test are related. And we'll see an example of that very shortly when we actually make use of describe. Now the last built-in function that we need to be aware of is the before each function. Before each is really a utility function that is used to extract some amount of logic that is common to a lot of our tests. So for example, if we have multiple it function calls where we run a test that are all doing some very similar setup logic, then we could use a before each function to extract that logic and only write that code out one time. Now, at this point, I've given you just a very high-level overview of these functions. And if you've never heard of them before, you're probably still thinking, wait, what's going on here? Well, to be honest, writing tests is one of those things where you just have to get your hands dirty. So I really just wanted to give you this high-level overview so that you would have some expectation of what would happen when we start writing our own test. So with that in mind, let's flip over to our code editor right now and start writing out our own tests. We're going to write these tests inside of our inbox.test.js file. At the end of this video, we'll end up deleting these tests, but of course, if you want to, you could always comment them out rather than deleting them. At the top of the file, we're going to write a little class that we're going to attempt to then test. And it's going to be a very straightforward little class. So we're going to make a class called car. Car is going to have 2 methods assigned to it. We'll have one method called park. Whenever someone calls park, we will return the string stopped. And then it will have a second method called drive. And whenever we call this, we'll return the string vroom. Now I think you can agree with me, this is a pretty straightforward test right here, or excuse me, pretty straightforward class. So let's now try writing out a little bit of code with Mocha to run some tests over this class right here and assert that calling park and drive both return stopped and vroom respectively. So underneath class car, we're going to first make a call with the describe function. Remember, describe is used to group together certain tests that are all testing the same subject or the same thing. So we'll call describe And then the first argument that we pass in is going to be a string. In this case, I'm going to pass in a string of car. Now this string doesn't have to be anything special. I'm not passing in the string of car right here because we're testing a class car. Like there's no intrinsic link between this string and the class's name. The string that we pass in to describe right here is solely for you and me. It's just so that we can have something to look at on our testing output report so we understand what set of tests we're about to run. So this can be car, or this could be car class, or it could be car class blah blah blah. It could be anything we want. It just is only used for organization purposes. The second argument to the describe function is going to be another function. So we're going to pass in an arrow function like so. This arrow function right here is going to contain all the different it test statements that we write that are supposed to be testing class car. So inside of here, we're going to ultimately have one or more it statements. Let's try writing one out right now. So I'll say it, and then just like with the describe function, the first argument is going to be a string that describes the purpose of the test that we're about to write. So maybe in this first it statement right here, we're going to test the park function of the car. So maybe I would provide a string that clearly indicates that we are attempting to test the park function. So maybe we could say something like it can park. This could just as easily have been something like it has a park function, or it park should return a string. Again, it can be whatever we want. Usually we just use it to have something easy to look at on a test output report and say, oh, okay, we understand what test is either passing or failing. So for right now, we'll just stick with it can drive. Or excuse me, it can park, my mistake. Now just like describe, the second argument is going to be an arrow function. And inside of this arrow function is where we are going to write our actual test setup and assertion logic. So again, our goal right now is to make sure that if we call park, we make sure that the string stopped is returned. So the first thing we're going to have to do is create an instance of class park. So inside the it block, we'll say const car is new car, like so. Then we can call park and somehow write an assertion that makes sure that we are returning the string stopped. To make this actual assertion, we're going to use that assert library that we had required in earlier. The assert library, you will recall, is a part of the Node standard library, and it has a variety of functions tied to it that allow us to make sure that one value is equal to another. Assert has many other functions that allow us to write effective tests as well, and we'll take a look at some of those as soon as we start writing actual code around our Ethereum contracts. So inside of the it block, we can write out assert.equal. Then we write out the value that is produced by our code. So in this case, it would be car.park. And then we pass in the value that we think it should be. So we think that it should be stopped, like so. So we're always going to do the value that is produced by our code and then the value that we think it should be. Assert.equal is then going to make sure that these two values right here are completely equal. If they are, then the test will pass, but if they're not, then the test is going to fail. Now that we have one test put together, let's save this file and figure out how to actually run Mocha inside of our project. So I'm going to save the file, and then to actually run Mocha inside of here, we're going to add a script to our package.json file, which you will recall is inside of our root project directory. Inside of package.json, I'm going to find the scripts section. You'll notice that there is already a test command here, but right now it says, hey, there's no test set up. So we now have a test set up, which means we can delete the text in there and then replace it just with the word Mocha, like so. Now at the command line, we can execute the command npm run test. That will automatically run this script, which internally is going to run the command Mocha. So we'll flip on over to our terminal. I'm going to make sure I'm inside of my project directory, and then I'll run npm run test. When I execute that command, you'll see the text right here, Mocha, appear on the screen, which means Mocha is running, and it takes just a second for it to pop up. Here is the describe statement right here. So we are describing the set of tests about our car class. And then underneath it, you'll see that our it statement of can drive gets printed out and it appears to be passing. So that's great. We've got one test passing. And we could just as easily go back to our test. Here it is right here. And if we change the value that we expect car.park to be to something like stopped, save the file, and then rerun npm run test back here, you'll notice that the test is now failing. And so honestly, this is an error message that you'll see way more frequently than the message saying that all of your tests passed. So very frequently, we will come over to our terminal, we'll run our tests, we'll notice that something went wrong, and we'll have to then do a little bit of debugging to figure out what happened. Now let's go back over to our test file, and we're going to fix this back up so the test is passing again. Cool, that looks good. Let's now create a second it statement. And in this one, we're going to test the functionality of our drive function. So in a second it block, we'll say something like it can drive. I'll place a second function. Inside of here, we'll make another car. And then we will assert that calling car.drive is equal to the string vroom right here. Cool. So we now have two tests nested in one describe block. Again, remember, describe is all about simply grouping together these sets of it statements. So let's now try running this test suite. I'll go back over to my terminal and we'll run npm run test again. Mocha takes just a second to warm up, and then we should see two tests passing. Cool. Now with that last addition of the second it statement right here, you'll notice that there's one thing that doesn't seem that great about our current test setup. Notice how both of our it statements right here and right here both have an identical first line of setup. So both of our tests need an instance of car before they can run. At present, we have duplicated that startup logic or that initialization logic inside of each it block. And one line of code duplicated might not seem like the worst thing in the world, but I'm sure you could easily imagine if we had many lines of setup that were necessary for each of these tests. If we had many lines, then we probably would not want to duplicate them between each it statement. So to handle that case, we can make use of that last helper that we mentioned, the before each statement. Before each is used to execute some general code setup that is common to many tests inside of our test file. So right above the describe statement, we can add in a before each call. We'll say before each, and then pass in another arrow function. Now, any logic that we place inside this function right here will be executed before each it statement inside of our code. So if we now put in something like console.log a, like so, and then ran our tests, we would expect to see this function run, then the it block run, then this function would run again, and then this it block would run again. Again, before each is all about doing some common initialization code for multiple tests. So let's now take this car declaration or this initialization and move it up to the before each. So inside the before each, we'll say const car is new car. And now we don't need it inside the it block here or the it block here. Now looking at this code, you might very quickly realize that something is a little bit off. Notice how we have defined a variable called car inside of this before each function. When we define a variable inside of a function, remember how scope works with JavaScript. The variable car is only available inside of this function or any other function nested inside of this thing. So maybe if we did something like const print car, then we could do console.log car. However, the car variable is not available inside of either of these it statements. If we ran our code right now, we would see an error message that says something like unknown variable or undefined variable car. So how do we deal with this? How do we somehow do initialization in a before each, but still get access to that variable inside of our it blocks? Well, it's a very straightforward thing that we're going to do here. We're going to take our variable declaration and move it outside and above the before each declaration. So rather than saying const car right here, I'm going to delete the const, and then above the before each, I'll say let car. So now, inside of the entire scope of this file, everyone knows that there is a variable called car that has been defined, or at least initialized. When we first initialize this, car will have a value of undefined because we've not yet assigned any value to it. However, when our test suite runs, remember that first we will execute the before each before any it statement runs. So we run the before each, the car variable is assigned a value, and then when the it statement runs right here, the car variable will not only be initialized, but it will also be assigned a value of new car. We'll make some assertion around the car. The before each will run again. It will redefine car with a new car, and then the second it statement can then execute again. So the entire trick here is to just understand that we need to define our car variable ahead of time and specifically define it with a let keyword. We're using let here because we're going to change the value of car. If we had used const, remember const is short for constant, and in this case, car is not constant. As our code runs, we're going to reassign the value that car holds. So we definitely want to use let here. All right, let's now run our tests again and see how we're doing. So at the terminal, we'll execute npm run test. And then as you see, we still have 2 tests passing. Okay, now that's a very short, very little introduction to testing with Mocha. But of course, we had to do just a quick review or refresher ahead of time before we tried to dump both testing and Ethereum on you at the same time. So I think that at this point, we've got a slightly better idea of how testing with Mocha works. And we've most importantly have a better idea of how before each, describe, and it works. If you still feel really shaky on testing, and to be honest, I really would expect you to if you've never worked with Mocha before, don't sweat it. We're going to write a lot of tests throughout this course. And the tests that you and I write are really never going to be that much more complicated than the structure that you see right here. So I think that you'll definitely get used to this idea of testing very quickly. All right, before we move on, I do want to do a little bit of code cleanup here. So I'm not going to keep any of this testing code around. So inside of the inbox.test file, I'm going to highlight everything from class car all the way to the bottom, and I'm going to delete it. Now, if you want to save it, if you want to comment it out or copy it into another file, certainly feel free, but I'm going to empty out my file here. Do make sure that you at least comment your code out. Otherwise, you might end up seeing some error messages later on as we start writing some actual tests around our contract. Whew, I think that's it. Let's move on to the next video where we're going to start writing some tests around our actual contract. So I'll see you there. We just got a good refresher on Mocha and how it works. Let's now take that knowledge and apply it to these Ethereum contracts. We're going to first start off by getting a good idea of how we're going to use Mocha at all to test Ethereum. We're going to repeatedly follow the same cycle that you see here on the screen. At the very top, Mocha is going to boot up and automatically load up our inbox.test.js file and start to execute the series of tests in there. Inside that file, we're going to go through this same cycle over and over again. The first thing we're going to do is to take our contract bytecode and deploy it to our local test network. Remember, that is called the Ganache local network. This will deploy a new instance of our contract. We will then write some code to manipulate that contract in some fashion. So maybe we will change the message that is stored inside of it. After that, we'll then make an assertion about a value that is tied to the contract. So for example, if during the manipulate process right here, we decide to update the message that is stored in the inbox, then immediately after, we would want to write an assertion that makes sure that our updated message is now persisted inside the contract. After that is executed, we then go back up to the top, deploy a fresh new contract, and then manipulate the contract in some other fashion, and then again, make an assertion about that. So it's the same process repeated over and over again. Now, taking this flow into mind and using our refreshed or newly acquired Mocha logic, let's take some common constructs that exist in Mocha and apply it to this flow right here. So we're saying that at the start of every test, we want to deploy a new contract. Well, it sounds to me like that is some common startup logic that is going to be common across every test we write. That's the entire purpose of the before each helper function. We use before each with Mocha to do some common initialization or configuration logic. So I think inside of a before each, we'll want to attempt to deploy our new contract. Then the process of manipulating the contract is going to be slightly different for every test that we write. For example, maybe one time we want to write a test that updates a message to a new value, and then in another test, maybe we don't want to update the message at all. So in every case, we probably want to manipulate the contract slightly differently. And that means that the actual manipulation should be placed into an it block that is custom for each testing scenario. And then finally, we're going to make an assertion about the contract. And as we've said several times, assertions are always placed inside of our it blocks. And so, yep, this is definitely going to go into an it as well. I'm sure that at this point, you're really tired of me lecturing and you just want to write these tests, but there's just one last little thing that I want to mention before we write code. So I swear this is the last thing. If you recall back to the contract that we had discussed deploying previously when we were making use of Remix, we had said that a contract is created through a transaction. Remember, we looked at this diagram right here. So we take an external account, and an external account is one that you or I create. An external account will submit a transaction with some compiled bytecode in the data field, and then the to field is going to be left blank. Now, how is that relevant to what we're doing right now? Well, remember, the entire idea here is that when we attempt to create a contract or deploy a contract to our local test network that is running through Ganache, we're going to have to make sure that we have some account that we can use to actually deploy it, like an account that you or I create. And so for that, luckily, you and I don't have to do anything extra. The Ganache module that we already installed and have configured inside of our project right here automatically creates a set of accounts for us to use as soon as that test network boots up. The good thing about these accounts is that they are created in an unlocked state. An unlocked account means that we don't need to do any special thing with any private keys or public keys to make access to, or to get access to. So we can just directly make use of the accounts that exist inside of this local Ganache network. Okay, I swear that's the last thing I wanted to mention, so let's pause right here. We're going to come back in the next video and we're going to write out our entire first test. So I'll see you in just a moment. No more stalling, no more lecturing. It's time to actually get started on writing some tests. In this video, we're going to make access to Web3 and use it to retrieve a list of accounts that are automatically created for us as a part of this local Ganache network. Remember, we can only deploy a contract when we have access to an account. So let's take a look at a diagram that's going to help us understand this. So you and I are going to use the Web3 library that has already been configured to connect to this local test network that gets started up by Ganache. We're going to use Web3 to access this list of unlocked accounts that are created automatically for us by Ganache. These accounts are defaulted as being unlocked or 100% accessible just to make our lives for testing a lot easier. When we say unlocked accounts, remember, it just means that we can freely send or receive Ether from these accounts without any concern over private keys or security or anything like that. Again, it's just to make our lives easier. So let's figure out how we're going to use Web3 to get access to these accounts. Inside of my inbox.test.js file, I'll first start off by defining a before each statement. So remember, the process of deploying a contract is something we are going to do every time we run a test. So chances are, every time that we run a test, we're going to want to grab our big list of accounts and then use one of those accounts to deploy our contract to our test network. And with that in mind, maybe we should put in some comments here to guide us. So right inside the before each, I'll place a comment that says, get a list of all accounts. And then underneath that, we'll say, use one of those accounts to deploy the contract. All right, so now the question becomes, how do we use the Web3 library to get access to a list of all unlocked accounts. Well, in practice, it's kind of straightforward. We're going to say web3.eth.getAccounts, like so. There's a couple things I want to mention about this. First, notice that we are using lowercase web3. We are using our instance of web3 that we have already created. To be 100% clear, we only make reference to the capital W web3 one time, and that's when we first require it in and then use it to create an instance. So we have lowercase web3 right here. The web3 library has many different modules assigned to it, and it can be used for working with different types of cryptocurrency. In this case, we are accessing one particular module, and that is the module that has to do with Ethereum, abbreviated here as ETH. So we're looking at the ETH module of the Web3 library. And then on that module, we are accessing the getAccounts function. There's one thing I'm going to tell you right now, and this is going to be true of everything we do with Web3. Every function, almost every, I almost want to say every function. Yeah, I think every function that we call with Web3 is asynchronous in nature. And that means that it's always going to be returning a promise. So this function right here is going to return a promise that gets resolved with a list of accounts that we care about. So to get access to that list of accounts that this thing returns, we have to chain on a .then, and that's going to take a function that will be called with our list of accounts. Maybe we'll just call this how about fetched accounts? That actually is important you'll see why in just a second. So we're going to call it fetched accounts right here. And then we want to just, maybe console log out the list of accounts that we've fetched. So let's say console.log fetched accounts, like so. Now to actually get this code to execute inside the before each, we do have to write out one test. So I'd like to just write out kind of a dummy test for right now, and then run this at our terminal so that we can see the console log of all the accounts that got fetched from our Ganache local network. So underneath the before each statement, I'm going to add a describe block. We're going to describe our inbox contract, and I'm going to place a single it deploys a contract. And then I'll pass that a arrow function as a second argument. So again, we're writing out an it statement right here just to make sure that our before each statement will run at least one time. We're not going to add any logic to it just yet. We'll come back in a moment and add that in. All right, so let's save this, and then we'll run these tests from the command line to make sure that the list of accounts is properly fetched. If you skipped the video about Mocha a couple of sections ago, then there is one small change that you have to make. Inside of your package.json file, find the script section and update the test script to say simply Mocha, like so. So if you skipped that previous video, make sure you make this change. And then once you do, we'll be able to flip on over to our terminal and run these tests. So inside of my inbox directory, I'll execute npm run test. You're going to notice that it actually takes quite a bit of time for these tests to run now. Well, maybe not just yet. It takes a little bit longer, I guess, because now we're actually getting access to Ganache, and that takes just a little bit of time to warm up. So after our tests run, you'll see a listing of 10 separate accounts. These are pre-generated accounts that are created by that Ganache local test network automatically. All 10 of these accounts are completely unlocked, so we can use any of them to deploy contracts, to send money, to call a function on a contract, anything we want to do. These 10 accounts are created just to make our lives easier so that we don't have to manually create an account every time that we want to run a test. So Ganache is really great in that regard. Do remember again that it is solely a local test network. It's only for executing tests and contracts locally, really just for development purposes. So it's really optimized to make our lives easier. Okay, so this looks pretty good. We've figured out how to use Web3. We figured out that there is a module called ETH that contains a lot of the different functions that are related to Ethereum. And we use the getAccounts function in particular. Let's take a break right now. We're going to come back to the next video and do just a little bit of code cleanup inside this file, and then continue on with our first it statement. So I'll see you in just a minute. As I mentioned at the end of the last video, just about every function that we call tied to Web3 is going to be returning a promise. Now, promises are great, and they're certainly better than the callbacks that we had to use with earlier versions of Web3. However, there's an even better syntax we can make use of to clean up this code right here. So rather than making use of promises throughout the rest of this course, we're going to be making use of the async await syntax. So rather than chaining on the .thens nonstop, we'll use async await to clean up our code and make it look more synchronous in nature. Let's see what that'll look like in practice. I'm going to highlight the entire .then and delete it. Then in front of the statement that produces a promise, which is right here, we'll place our await keyword. Then in front of that, we'll assign this value to an accounts variable. Whenever I use await, I have to make sure that the function that it is contained in is marked as being asynchronous in nature. So right before our arrow function that gets passed to before each, we'll mark it with an async, like so. And then the last step, and you'll recall when we were just looking at our quick review of Mocha a couple of videos ago, we had said that whenever we want to get access to a variable declared inside of our before each, inside of an it block, we have to define that variable ahead of time with the let keyword. So right before the before each statement, we'll say let accounts, like so. Now, whenever this file is executed, the accounts variable will be defined. The before each statement will run. It will grab the list of accounts. It will wait for that request to be completed, and then it will assign that list of accounts to the accounts variable. Then we can go ahead and add a statement inside of our it block down here that makes use of those accounts. So just to make sure this is still working the way we expect, let's do a console log of accounts, like so. And let's flip back over to our terminal. We'll run npm run test again, and we should still see that list of accounts appear on the screen. Great, looks good. Throughout the rest of the course, we're going to be making use of async await. And I don't think there's a single instance, maybe one or two, in which we will actually use promises rather than using async await. So over time, we're going to see a lot of use of this newer syntax, and it's definitely going to do a lot to clean up our code. Let's continue in the next video, and we're going to figure out how to make use of one of these accounts to deploy our contract. So I'll see you in a moment. We've got our list of accounts, which means now it's time to actually use one of those accounts to deploy the contract. To deploy the contract, we need to get access to the contract's bytecode that it has been produced by our compile.js file. So here's compile.js right here. Inside of it, you will recall that we used the Solidity compiler to compile our contract. And from this file, we are returning only the definition of our contract inbox. It was a couple of videos ago, but I want to remind you that this contract that we are exporting from this file has two properties assigned to it in particular. One is called interface, and the other is bytecode. The property interface is the JavaScript ABI, and bytecode is the actual raw compiled contract. We're now going to import both those properties from the compile.js file into our test file over here. And once we get access to that bytecode, we can then use it in conjunction with Web3 to create a new deployed instance of our contract. So underneath the last require statement up here, we're going to add in const interface and bytecode. Oops, not and. Interface and bytecode. And we're going to require that from the compile file. Remember that compile is up one directory, which is why we have the ... right here. And again, you'll recall from that previous video, we had a property on this exported object of interface and bytecode. So I'm not making these up. These are properties that we had seen in that previous video. Now that we have the definition of what a contract is, and we have an account to deploy it from, we can actually deploy the contract. Now there's a pretty good amount of code that goes into the deployment process. We're going to write out the code right now, and then we'll talk about what every line of code does. So first, we're just going to write it all out, and then we'll discuss it. So let's get started. We're going to say new web3.f.contract. Now notice that contract right here has a capital C. It's a constructor function, so we are creating an instance of a contract. And then after that, we're going to pass in json.parse interface, like so. Underneath this, we're going to call .deploy. So this is a method that we are chaining on to the object that is returned from contract right here. We're going to deploy. We're going to pass in an object. This is going to have two properties assigned to it. The first will be data. Data is going to be the actual bytecode that consists of our contract. And then the second argument will be some initial startup arguments for our contract. If we go back over to our contract, you'll recall that our contract's constructor function expects to be called with a string that initializes the message property. So whenever we create a new instance of our contract, we have to pass in some initial message to it. So we're going to say arguments is going to be an array. And for the initial message, I'm going to use hi there. The initial message right here can be anything you want it to be. Maybe best if you just use hi there right now, because that'll make writing the tests easier for you and me later on. After calling deploy, we're going to add on another dot down here. We're going to say dot send. We're going to pass an object into this one. We're going to say from accounts at 0. This is specifying the account that we want to deploy, or excuse me, the contract that we want to deploy the account from. So this is essentially the person who is deploying the account. And we're just going to use the first accounts in that accounts array. And then we will also specify the gas that can be used to deploy the contract. Remember, anytime we modify the blockchain, we have to spend some amount of gas. So we're going to say that this deployment can use up to 1 million gas. So it's going to be 1, 0, 0, 0, 0, 0, 0, like so. Now we're not going to leave the commas here. I put in the commas just so you can see that I am putting in specifically 1 million. So make sure you've got 1 million here. And then I'm going to take those commas out. All right, now the last thing I want to do is I think it'd be really nice if we could console log out whatever contract is created by this. So just like before, where we did some variable initialization, we're going to do the same thing for a variable called inbox. So we'll say let inbox, and then we will assign the contract that gets created and deployed right here to the inbox variable. So I'll say inbox equals all this stuff. As you might guess, creating and deploying a contract is an asynchronous operation, so it takes some amount of time to complete. So we do have to add in the await keyword right here. So right before new, we're going to say await. And then the very last step inside of our it statement down here, we're going to replace the console log accounts with a console log of inbox, like so. Ooh, a lot of code. So we're going to discuss exactly what it all does in just a moment. But first, let's test out our deployment. All right, I'll flip back over to my terminal and I'll run npm run test. You're going to notice that it takes a little bit more time for our test to run now because we have to do that compile process. But hopefully after they run, we should see our deployed contract. Awesome, here it is right here. So this is the deployed contract. We're going to go over all the properties that are in here, or at least some of them, in just a moment. But for now, let's take a quick pause and we'll come back and discuss the code we wrote and interpret that console log that we just saw at the terminal. So I'll see you in just a minute. Now that we've written out some code to deploy our contract, let's break this statement down right here and figure out exactly what it's doing. Remember, this is all code that is tied to the Web3 library, and the Web3 library is our sole means of interacting with an Ethereum network. It's really our portal to everything that's going on with Ethereum. So we're going to take this code and break it down line by line. We'll first start off by talking about the first line on here, which is new web3.eth.contract. Just a moment ago, I had explained to you that the Web3 library is not only intended for use with Ethereum, so it can be used with other types of interesting web technologies as well. In this case, we are accessing the Ethereum module, and in particular, we're accessing the contract property. Contract here is a constructor function, and its intent is to allow us to either interact with existing contracts that exist on the blockchain already, or to create and deploy new contracts. The first argument to the contract constructor right here is our ABI. Remember, the ABI is how we get some intermediation or some conversion or some interface between the Solidity world and the JavaScript world. You'll notice that I said json.parse here and passed in the interface property. When the compiler, the Solidity compiler, compiled our contract and it spit out that interface, it spit out a JSON representation of our interface. We don't want to pass JSON to contract right here. We want to pass an actual JavaScript object. And that's why we specifically parse that JSON to get back a JavaScript object. So this first line in total essentially tells Web3, hey, there's a contract out there and here's the interface that it expects. That first line says nothing about whether this contract has been deployed or whether we're trying to create it. It also says nothing about the data that exists inside the contract. It says nothing about a specific contract. This first line really just tells Web3 there is a type of contract out there that kind of has this interface that you can conform to in order to communicate with it. The second line is where things start to actually get interesting. So once we have this generic contract object at the top, we then customize it a little bit by chaining on these additional methods of deploy and send. The deploy line, as you might guess, is what actually tells Web3 that we want to deploy a new contract. This starts to create a transaction object that has the data property. You'll recall that data is where we specify our bytecode for the contract. And it also has the arguments property, which you will recall is a list of arguments to pass into the constructor function of the contract when it is created. So this argument right here, the first argument in the arguments array, will be received into our contract, our inbox contract right here, as a constructor argument for initial message. The reason that arguments is an array is that the constructor function could potentially accept multiple arguments. So if we had another argument to this thing of like string, I don't know, creator or something like that, then we could have passed in a second element inside of that arguments array. So we could have passed in another element right here, and that would be received into our constructor function as the second argument. So essentially one-to-one mapping from the arguments array to the list of arguments that the contract constructor function expects. Now the last line is what actually takes this idea of a contract that has been customized with some amount of code and deploys it to the network. So calling deploy doesn't actually deploy anything. Calling deploy starts to create an object that can then be deployed to the network. It's the send method that actually triggers the communication from Web3 off to the network. The send function takes both a from property, so this is the person or the account that is being used to create the contract, and then the gas property, which we had described a couple of videos ago. So this is pretty verbose, but this is what goes into the creation of a deployed contract. Now, while we're talking about Web3 and contracts in general, there's one thing that I want to make really clear, because this is something that is kind of challenging to understand when you're just looking at the Web3 documentation. All right, so here's what it is. The Web3 library is not only for use in deploying contracts. We can also use Web3 to get access to contracts that have already been deployed to the network. And in fact, we're going to do that many times throughout this course, because eventually we're going to deploy a contract and then try to interact with it after the fact from some JavaScript application. So we've got two sides to the coin here with Web3. We can use Web3 to create and deploy a new contract, or we can use it to kind of assume or get in touch with or communicate to a contract that has already been deployed. Depending on what we're trying to do, we need to have different amounts of information. If we are trying to interact with a contract that has already been deployed, we need to know the ABI so that we can translate what the contract is trying to do over to JavaScript. We don't need the bytecode in this case, because we're not trying to understand what the contract is doing internally. We're just trying to interface with it in some fashion. So if we are just interacting with a contract that has already been deployed, we don't need the bytecode. And then finally, if we're trying to interact with a contract that has been deployed, we need to actually know where that thing has been deployed to. So we need to know the address. Remember, any contract can be deployed an unlimited number of times. So whenever we want to talk to a specific address, or talk to a specific contract, we have to provide the address that contract has been deployed to. If we are trying to create a contract, which is what we are doing right now, we need the ABI, we need the bytecode, because this is what actually says what the contract does. But in this case, there is not yet an address in existence. We don't yet have an address. So we don't need an address in this case. Once the contract has been deployed successfully, then we will get an address back. And that address will say, hey, here's where the contract exists. All right, so again, that's just a thing that I want to throw out there that can be kind of confusing when you just read the Web3 documentation. Now, the last thing I want to remind you is that whenever we deploy this contract, that is an asynchronous operation. That's why we put the await keyword right here, to make sure that, hey, we wait for this thing to actually be deployed successfully. The value that is returned from all this is a direct reference to the inbox contract. So we look at this value right here. This is like our JavaScript representation of the contract. We can interact with this object and call functions on it that actually correspond to the contract over here. So in other words, this object right here represents what exists on the blockchain. We can call functions on it to interact directly with the contract that exists on the blockchain. And we're going to see examples of that very quickly as we start to write some more tests around that thing. Now, the last thing I want to do is a quick review of what we just saw console logged at our terminal. So I just want to step through a couple of properties that are on here to give you a better sense of that inbox object. So I'm going to scroll up to the top of the console log. Here it is right here. So this is an object of type contract. And this is a contract that has been constructed by the Web3 library. You're going to see a lot of different pieces of information about things about the provider. So remember, the provider is the communication layer with the actual blockchain. You'll see some stuff around request manager. This is tied to the provider, and it helps facilitate communication with the actual blockchain. Very interestingly, you'll also see a list of providers right here. So whenever we provide a provider to Web3, there are 3 types of providers that we can designate. It can be a provider that communicates over WebSockets. It can be one that communicates over an HTTP connection, and then one that communicates over IPC, or inter-process communication. IPC is used whenever you are running a blockchain, or a network on the same machine as your test, whatever you're using for your test setup as well. Now, in general, we're not going to have to work that much with some of these different providers, but there are a couple notes that I will give to you over time about each of them. So for right now, I just want you to know that some of these different providers exist. Now we can keep scrolling down a little bit, and I think that's pretty much all I want to point out for right now. There are a couple, here we go. So we see, yeah, here we go. My mistake, there's just a little bit more. So the methods object right here, this is probably the most important property on this object that we're dealing with. So methods right here are the actual functions that we can interact with that are tied to our contract. On the methods object, you'll see a property called setMessage and a property called message. These are both functions. So we can call both of these. They will have the exact same effect as when we had been working with this contract over in Remix. You'll recall over here, after we deployed a contract, we could click on either message or set message to interact with those functions. Clicking on these buttons is the exact same thing as calling set message right here and calling message right here. So we're going to be using these methods quite a bit in just a moment to write some actual functional tests around our contract. Now, I think maybe the last thing I want to mention here is the options address. Options contains some information about the actual contract that was just deployed. And most notably, it contains the address property. You'll notice that there is also an underscore address property right here, but usually by convention, we get access to the address by looking at the options.address property. So again, this is the address that the contract now exists at. Recording the address right here is eventually going to be important when we start to deploy our contracts to the main network. Of course, once we deploy a contract, we want to know where it exists on the blockchain. And so we will want to get access to the address right here. But for right now, for just the purposes of writing some tests, well, not quite so important, but we might write 1 or 2 tests just to make sure that the address exists. Okay, so that's a little bit of an overview on the code that we just wrote. I know that we're going kind of slow right now, well, actually really slow, but this is some of the biggest complexity around Ethereum. So honestly, I'm speaking dumping my knowledge as fast as I can. Hopefully it's fast enough for you. So let's now continue in the next video. We're gonna start to write some actual meaningful tests around our inbox contract. So I'll see you in just a minute. We finally have a list of accounts and a deployed instance of a contract, which means it's time to actually write some meaningful tests. Now that might just lead to a can of worms in its own. You might be wondering, well, what exactly are we testing here? Fortunately, we've got a rather small contract, which means it's going to be pretty straightforward for testing. I want you to look at this contract right here. And remember, this is essentially just a contract that stores some tiny little string. And I want you to imagine what behavior about this contract is kind of important for its functionality. I think that probably there's two big things that come to mind around this contract. First off, I want to be sure that if I ever initialize an instance of this contract, it sets up some default value for this message property right here. So I think that maybe we should have one test that just makes sure that whenever we create an instance of the contract, we get some default message assigned. The second big thing that I would want to test is to make sure that once we call setMessage with a new message to store, we should make sure or make some type of assertion to make sure that the message property gets updated as well. So I think that's the two big things I would want to assert, or the two big things I would want to test. I want to make sure that this contract gets a default message, and I want to make sure that I can change it in some fashion. So I think we should write tests around both those cases. And maybe we should write one other test as well. Maybe we should make sure that our before each logic right here is working properly. So maybe we should have one more test that just makes sure that we are able to successfully deploy a contract. To make sure that we are successfully deploying something, I think we can probably just make sure that our inbox object right here, and remember this represents our contract, we can probably just make sure that this thing gets an address assigned to it. The presence of an address means that this contract has likely been successfully deployed to the local Ganache test network right here. So inside of this first it statement, I'm going to leave the text it deploys a contract the same. But we're going to update the body of this function, and we're going to make an assertion to say that the inbox contract does get an address assigned. At this point, we've only looked at one type of assertion. We've only looked at the assert.equal assertion. But there's another function on the assert module that we can make use of here, and it is called assert.ok. So we're going to write assert.ok and then pass in inbox.options.address. All right, so let's talk about what this is doing here. First off is the address property on the options object. Remember that we just looked at the console log of inbox a moment ago, and we had said that it had an options object. One property on there was address. After we deploy the contract to the test network, this address property will contain the address of wherever this contract was deployed to. So just by looking up this property on this object, if an address exists here, well, okay, I feel pretty confident in saying that the contract was probably successfully deployed. Now on to the assert.ok method. First off, remember that the assert method or the assert module is a part of the Node standard library. The OK method right here makes an assertion that whatever we are passing into the function is a value that exists. So the OK method right here is essentially saying, is this a defined value? If inbox.options.address is null or undefined, then this test will fail. But if it is any truthy value and a string, which is what the address is a truthy value, then the test will pass. So let's save this file and run our tests and see how we're doing. Back at the command line, we'll do npm run test again. We'll wait for a moment for the test or the contract to compile, excuse me. And it does take a couple seconds every time. It's just that just long enough to feel a little bit awkward. And there we go. So it looks like we are successfully now passing that test. In general, I do always recommend starting off with a very simple test like this, just to make sure that your deployment process is working correctly. So for example, let's say maybe we had failed to actually send our transaction to the network. So notice that I just commented this line of code right here. So now we are only initializing our contract and telling Web3 that we want to initialize or start to configure its deployment. But we haven't actually sent a transaction to our test network to actually create the contract. So now, if we run npm run test with this, I would expect to see a failure. I would expect to see something that says, hey, property doesn't exist. And we should see that it has deployed successfully, has not been defined. All right, so yep, looks like we got cannot read property address of defined. So again, this is a nice quick test just to make sure that we have successfully deployed our contract. All right, now I'm going to uncomment the .send method, which means our test should be passing again. Now let's pause right now. When we come back in the next video, we're going to start to write a test to make sure that we are able to create our instance of the inbox contract with an initial message. So we'll take care of that in just a moment. In this video, we're going to write a test to make sure that when we deploy our inbox contract, we get some initial value for our message passed in. This is definitely going to be our first very real test. I know this has been a tremendous amount of buildup, but again, we're covering a lot of different topics here at the same time. We're talking about contracts and Web3 and the test network and Mocha. So even if it feels like we're going slow, honestly, it's probably for the best. Now, inside of our describe block right here for inbox, we're going to add another test. To add another test, we're going to add an it statement. For this message, I want to make sure that when we create a new contract, we get a default message. So I think I'm going to give this a description of it has a default message, like so. Now inside of here, we're going to need to write some code to somehow look at the inbox and somehow pull off this message property right here. That's definitely an interesting one. You'll recall that when we made use of Remix back over here, we could get access to the message property just by clicking this button. So when we clicked on message right here, we were calling a method or invoking a method on the contract to get access to the message instance variable. You'll also recall that because we specified this message variable was public, we automatically got that method generated for us. Now there's one thing I want to remind you about that's really important here. We had looked at this diagram previously. Now we looked at this many videos ago, so let me give you a quick reminder. Remember that there are two ways in which we can invoke a contract function. On the one hand side, we can call a function, and we call a function anytime we want to simply read data out of a contract. When we call a function, we instantly get back some amount of data, or at least relatively instantly. When we call a function with Web3, it's still an asynchronous request, but we don't have to wait for any transaction to be confirmed by a network or anything like that. So when I say runs instantly, well, it's relatively instantly. On the other hand, we had spoken about how we can modify a contract's data when we send a transaction to a function. So when we're thinking about the current case we are in right now, when we're thinking about somehow retrieving the message that gets set by default when we create this contract right here, I think that we want to call a method on our contract. We want to call a method because we want to retrieve a value off of our contract, and we don't want to modify any data that is tied to it. So inside of our test right here, we're going to write some code that is going to attempt to call a method on our inbox contract. Now the first thing I'm going to do here is I'm going to mark this function as being async. Remember what we just said a moment ago. Calling a method is like relatively instantaneous. It's still asynchronous, so we still have to assume that calling the method is going to return a promise, and we still have to wait for that promise to be resolved. So we're going to use the async await syntax to wait for this message property to come back to us. Now I'm going to say const message, so we're going to assign the initial message to this variable right here, and then we'll say await inbox dot methods dot message dot call. All right, so let's look at this line carefully because this is a little snippet of code right here that we're going to be writing many times throughout this course. First off, we reference the contract. I think that's clear enough. This is an instance of the contract. It's a JavaScript object that represents the contract that exists on the blockchain. Our contract has a property called methods. Methods is an object that contains all of the different public functions that exist in our contract. So if we go back over to the source code over here, we would have two methods defined on our contract. We would have setMessage and message. Those are the two methods that are tied to our contract right now. So you can see that we are referencing the message property right here. If we wanted to somehow call, say, setMessage instead, then rather than calling methods.message, this would be setMessage. But of course we want the message here, so we're going to call this. Notice that when we call the method, we have, or when we reference this method, I should say, we immediately set one pair of parentheses right here. So when we call message, or when we're trying to call this method on the contract, we're going to have two sets of parentheses. The first one that is tied to the actual method, and then we have a second set of parentheses that's attached to the .call that comes off of that. The way to remember this, or the way to understand what these two sets of parentheses are doing right here, is that the first set, we're going to pass in any arguments that this function might require. When we call the message, or when we try to retrieve the message property off of our contract, that doesn't require any arguments to be passed to it. However, if you look over at setMessage right here, this one does require an argument. So if we are trying to call a function that requires some arguments, we would pass those arguments into this first set of parentheses. The second set of parentheses are used to customize the transaction that we are attempting to send out to the network. So if this was not a call that we are doing to a function here, if this was actually us attempting to send a transaction, we might pass in an object that specifies exactly who is going to pay for this transaction and how much gas to use. And remember, when I say send, I'm talking about whenever we want to modify a contract's data. So again, we can think of the first set of parentheses as being some way to customize the list of arguments that's being passed to the function, and the second set is going to customize exactly how that function gets called. Now we're going to come back to this topic of discussing these two sets of parentheses many times, so I'll give you many reminders of when we're going to use one set versus the other. We'll see a lot of examples of it as we work with more code. So this is going to retrieve our message, and then the last thing we want to do here is to assert the value of the message. When we first initialized our contract up here, we gave it an initial message of the string hi there. So when we get this message back, well, it should definitely be the string hi there. So I'm going to say assert.equal message and hi there. To make our test a little bit more robust, we might decide to assign the string hi there to a variable up here at the top, maybe something like initial string equals hi there. And then we could reference this variable for arguments down here and for when we do the assertion down here. And that would just make sure that if someone ever comes along and modifies our test and decides, well, you know, hi there is a boring message, I want to do like bye there instead. If someone just changed this argument up here, then it would instantly cause our test to break. And an easy way to get around that is to instead reference one common variable. Now I'm not going to do that here for no good reason, but certainly if you want to, you could use that common variable in each location. All right, so let's save this and run our test at the command line and see how we're doing. So I'll run npm run test. And again, we have to wait a couple seconds. This delay is coming from the compilation process. Now we could decide to, say, compile our contract to a single file and not have to recompile every time we run our test, but honestly, that's just a little bit more effort. So I think we've got an easier to use solution right now. Okay, so here's our test. It looks like it's passing. So that means that any time that we deploy an instance of our contract, we are definitely getting some default message set on this instance. So this looks good. Let's continue in the next video, and we're going to write one more test to make sure that we are now able to update this message over time and then retrieve it again off the instance. So quick break, and we'll take care of that last test in the next video. The last test that we're going to write is going to be intended to target the setMessage function right here. So we want to create our new instance of the contract, which we're already doing in the before each method. We're then going to attempt to modify the message by calling setMessage, and then we're going to retrieve the message again by using the automatically generated function message. So let's write this test out inside of our test file. I'm at the bottom of inbox.test.js, and we're going to add another it block inside of here. So I'm going to say it can change the message. I think that's reasonably descriptive. Now I probably can make a very reasonable assumption that we're going to use some asynchronous code inside this method, so I'm going to mark it as being async. Now inside of here, we have access to the inbox instance from right here that we defined in the before each. So I think all we really have to do is attempt to change the message and then retrieve it, just like how we did from the previous test, and then make sure that it gets updated in some fashion. So in total, I think we really just need one new line of code. We just need to figure out how we can change the message. To change the message, we're going to again reference inbox.methods. So this methods object right here is something that we're going to touch again and again and again. Remember, it's the way that we get the ability to change some data or retrieve data from our contract. This time, rather than calling the message function, we're going to call the set message function. And we're going to place the first set of parentheses immediately after that. Now remember what we just discussed in the last video. This first set of parentheses right here is going to take some arguments that are going to eventually get forwarded on to the set message function. So whatever we pass into that first set of parentheses will show up in this function as the new message. So for me, I'm going to pass in a new message of, how about just buy? Now calling set message isn't enough. After calling this function, we have to then kind of like send this thing out to the network. So we do the initial setup right here, and then we have to actually send this transaction out to the network. This goes back to the same topic we were just discussing a moment ago. So we were just a moment ago retrieving some data off of our contract, and to do that we were calling a function. But this time we are definitely without a doubt trying to modify our contract's data. Without a doubt, that's what we're doing this time. Whenever we want to send a transaction to a function, we have to specify where the transaction is coming from, or it would be better to say who is issuing the transaction. So we're going to call a method on this thing called .send. You can think of send right here as being like send transaction. That's what's really happening behind the scenes. And then we're going to pass in an object that describes who is paying for this, who is paying the money, who is paying the gas to actually modify some data inside of our contract. This is, again, where it's really handy that the Ganache CLI automatically creates a set of accounts for us right here. So when we want to say who is going to pay for this thing, we can simply say this message is coming from accounts at 0. So accounts is our array of account addresses. We're going to take the first address out of there and have that person pay for sending this change into the network. Now the last thing to keep in mind is that, yep, this is an asynchronous action right here, so we have to wait for it to be completed. We're going to mark it with await, like so. Now one thing I want to remind you about, whenever we send a transaction to a function, we get back the transaction hash. We get back a little bit more information than just the transaction hash, but essentially we just get back an object that you can consider to be kind of a receipt for the transaction we sent in. So we're not going to get back any actual message. Nothing's going to come back and say like, oh, here's the message that was just set. So usually whenever we send a transaction to a function inside of tests, we usually don't assign the result to any variable because we get back the transaction receipt, and honestly, we can just assume that the transaction occurred successfully. If the transaction does not occur successfully, then this method right here is going to throw an error, and that will cause our entire test suite to fail. So we don't really have to put in an additional thing here to take the transaction and verify that it went through okay. If everything happens okay, then this line of code is going to proceed, and we're going to go to the next line of code. If something goes wrong, an error is just going to be thrown, and that's going to be our signal that we need to do a little bit of debugging. So with that in mind, we can really just do the next two steps, which are going to be to retrieve the new message that just got set, just like we did up here, and then to assert that the message got updated successfully. So let's add that in as well. We'll say const message is going to be await inbox.methods.message.call. And do make sure that you get both sets of parentheses here. That's a super easy typo to make. I can almost guarantee it that you'll make it one time in this course. And then finally, we're going to assert that the message that we just retrieved is equal to the string by, because that's what we just attempted to update it to. All right, so let's save this. Let's run our tests and see how we're doing. So I'll npm run test. We will again wait that very awkward 5 seconds. And then we'll expect to see that both of all three, I should say, of our tests have passed. And it looks like they all did. Great. So that's pretty much it for writing tests around our contract. This is definitely one of the simplest implementations that we can effectively test inside of a project, but we will be writing other tests or working on other contracts in this course that are going to get far more complex and a little bit more difficult than what we see here. So this was a very good place to get an introduction and a warm up to testing. Now let's continue in the next video. We still need to work on deploying this contract to a local network. So let's take care of that in the next video. The last thing that we have to do inside of our project is write a little script to take our contract, so our inbox contract right here, compile it, and then deploy it to a real test network. And that's kind of conflicting when I say that, real test network, but basically I want to deploy this script or this contract out to the Rinkeby network. In this case, we're going to deploy to Rinkeby, but we could just as easily deploy this to the main network. We're only using Rinkeby because remember, we have to pay real money to deploy our contracts, and I'm going to assume that you probably don't want to pay money to deploy this thing right here. Once you learn how to deploy a contract to Rinkeby, it's the exact same process to deploy it to a main network. So we're going to get some pretty good knowledge right here. The process of actually doing the deployment is going to involve some code that looks very similar to what we did a moment ago inside of our test file. So here's our before each statement inside the test file. Remember, we created a new contract, we then called deploy on it, and then we called send on that. So eventually we're going to do the same thing as we did right here. But there's going to be just a little bit of added difficulty because you and I need to kind of understand exactly what is different between deploying to a local test network where all of our accounts are unlocked and open for access versus a real network where we have to somehow get an account that has some amount of Ether in it already. So in this video, we're going to take a look at a complicated diagram that's going to help you understand exactly how this deployment process is going to work. The first thing I want to do here is remind you about the concept of the Web3 instance and the provider. So we've got an instance of Web3, which is our portal to all things occurring in the Ethereum world. And a Web3 instance doesn't operate on its own. We have to set a provider on the instance, which is how Web3 communicates with some given network. So again, you can imagine that this provider kind of gets inserted into this Web3 instance like so. So I want you to keep that in mind for just a moment, because we're going to look at another diagram that's going to add a couple more pieces to this puzzle. Okay, so here we go. So like I said, a couple more pieces here. We're going to spend a little bit of time talking about this diagram, and then we'll take that knowledge and apply it in our deploy script in the next video. So we're going to start off at the right-hand side and talk about what is similar about deployment to a public test network and what is dissimilar. So just as before, we're going to use a Web3 instance to facilitate our deployment process. We're going to create the instance, we're going to shove a provider into it, and that provider is going to tell our instance exactly what network it is supposed to be communicating with. Now this time around, there's one big difference here between deploying to the test network and deploying to our local network. That big difference is the fact that this time around, we have to make sure that we are using an account that has some Ether on this test network or on the Rinkeby network. So before we just said, hey, take some account that was pre-generated for us, some account that is already unlocked on our Ganache local network, and just go ahead and do the deploy. And you and I didn't have to worry anything about security or private keys or public keys or anything like that. But this time around, again, we're using a real account here. We're going to spend some kind of fake, but also kind of real Ether to do this deployment. So this time around, our provider needs to have an account that it's going to use as a source of Ether for the deployment. To do that, we're going to take what's called our account mnemonic. The account mnemonic was that 12-word phrase that was provided to us by MetaMask when we first created our account a while ago. So you'll recall when we created an account, it said, hey, here's your mnemonic, it's 12 words, write this down and don't lose it, because it is the only way to unlock your account. So that account mnemonic is kind of a stand-in not only for your public key, but also the private key. In just a little bit, we'll talk about exactly what the mnemonic does for us. But essentially, that mnemonic can be used to unlock your account and use the ethers within it to deploy a contract. So we're going to take that account mnemonic and pass it to this provider that you and I are going to create. Previously, we used a provider that was given to us directly by Ganache. And so that provider already had some of those accounts or this account information kind of installed inside the provider. So the big difference here is that this time around, we don't get those automatically created accounts included in the provider. We have to set that thing up ourselves. So we're going to take the account mnemonic and shove it in there. Now the next big difference is that once we start attempting to deploy to the Rinkeby network, we need to make sure that we have some node that we can connect to actually deploy our contract. Remember, whenever we think of the Rinkeby network, it's not just this one singular box as I've kind of depicted it here that we are connecting to. We have to connect to a very specific node. Well, maybe not specific node per se, but we have to connect to a node that exists inside the Rinkeby network. One of the common solutions you'll see around this is to run a local node on your own machine. So a real Ethereum node that connects to the Rinkeby network. And you can then use that node running on your machine to deploy your contract. However, that's a process that takes a lot of time and a lot of difficulty to set up. So rather than using a local full Ethereum node, which would take us a lot of time and a lot of effort, we are instead going to use a service called Infura. Infura is a public API that we can sign up for. It gives us the ability to get access to a node that is hosted on the Rinkeby network by Infura. Essentially, think of Infura as being our portal beyond Web3 into the Rinkeby network. The company that runs this Infura API also has nodes that are available on the main network, on Ropsten, on Kovan, and basically all the public networks involved with Ethereum. So it's a very easy way to get started with deploying and accessing the network. Okay, so that's pretty much it. That's some of the different pieces of the puzzle. Now, as usual, I've given you a little bit of a high-level overview here, and we haven't gone too far into the details just yet. Because if we went through the details, well, this would be a 20-minute lecture, of course. So a lot of the skills and knowledge we're going to pick up here is going to be in the form of actually writing this code out and seeing how it all works. So let's pause right here. We're going to continue in the next video, and we're going to start to set up some of these different pieces inside of our deployment script. So I'll see you in just a minute. In the last video, we spoke about some of the architectural changes that our app is going to go through in order to deploy our contract over to the Rinkeby network. The first thing we're going to do is to sign up for the Infura API. Remember, this is a service that gives us direct access to the Rinkeby network. If we didn't have access to the Infura API, we would have to run a node on our own personal machine. That node would connect to the Rinkeby network, and we could then use that node to deploy our contract. But that is a process that is a real pain in the rear and takes a lot of time and effort to go through. So instead, we're going to use Infura. We're going to first start off by signing up for the Infura API and getting an API key. At present, Infura is 100% free, so there's really not a lot we have to give up to make use of Infura. Inside my browser, I'm going to navigate to infura.io. And I'll put this link on the screen nice and large so you can see it. Okay, infura.io. Once there, we're going to find the Get Started button right here at the center. One thing I want to mention about Infura is that they change up this homepage very frequently, so you might be seeing something that looks different than what I see. Essentially, what we want to do is find something that says Get Started. No matter how they change the design, you'll usually see something that says Get Started or Sign Up. So I'm going to click Get Started, and then it gives us a series of instructions on how to make use of Infura. The first thing we do is sign up and register for an access token. So this is the API key that we need to get. This is something that says, hey, here's some unique identifier that allows us to connect to the service. This access token is not tied to any specific Ethereum account or any network. It's solely a token that allows us to connect to Infura. So we're going to go to the register link and we'll sign up for their service. So you can enter in your name and your email. I'll put mine in. And of course, I'm not a robot. Hopefully I don't have to do any CAPTCHA. Okay, that's very good. And then I'll submit. Now, I do not recall off the top of my head if you have to go and click on some email. Oh, well, isn't that fantastic? We get a nice 404. Did you see that? Well, hopefully you had more success than I. So you'll probably want to pop open your email and try to find the key. They should have sent you an email to actually get your key out of there. So let me pull mine up really quickly. On my second screen, I'm going to pull up my email and we'll take a look at the email together. Here we go. All right, so this is what we're looking for. Here's what we're looking for. So you'll see a collection of different links that we can use to access the Infura API. At the end of each of these links, you'll see a string of characters and letters. This is the actual access token or the API key. You'll notice that is the same for each of these links. The only thing that changes between each of these links is which network we are attempting to connect to. So at the very top, we have a link to access the main network, then Ropsten, Rinkeby, Kovan, and you get the idea. Now that we've got this link, we can start putting it to use inside of our deployment script. So I encourage you to hold on to this link from your email for just a moment. We'll continue in the next video, and we're going to put this link to use almost immediately. So quick pause, and we'll come back and start setting up the script. Now that we have a link for the Infura API, we're going to install a module or two and then get started with our deployment script. We're going to first flip on over to our terminal and install one module that's going to help us in creating a provider that will connect to the Infura network. We'll talk about exactly what this package is doing in a moment, but first let's start off the installation process. Once again, I'm inside of my inbox directory, and I'm going to run npm install --save truffle hd wallet provider, like so. And let me zoom in so we see that entire statement on one line. So truffle hd wallet provider. And we'll let that do its thing. All right, so back over to our diagram. Let's get a better sense of exactly what that module is doing for us. So we were just looking at this diagram a moment ago, and we had said several times now that the provider is how our Web3 instance talks to some particular network. We just installed a special provider that allows us to not only connect to some outside API or some outside node, but it also allows us to simultaneously unlock an account. So remember before, when we made use of the Ganache CLI just a moment ago inside of our test file, we had a very easy time setting up the provider. We just said ganache.provider, and that instantly allowed us to connect to this local test network and also unlocked a couple of accounts for us. This time around, we have to set up this provider manually. And when we set up the provider, we need to specify exactly what network we want to connect to. And we also need to use it to somehow unlock an account that will be used for all the different deployment requests that we make. So that's why we are installing this module. The Truffle HD wallet provider is going to be this part right here. It's going to allow us to connect to the Rinkeby network hosted through Infura, and it's going to simultaneously, and more importantly, allow us to very easily unlock an account to use. So let's flip back over to our code editor, and we're going to get started with our deployment script. Inside of my root project directory, I'm going to make a new file called deploy.js. At the very top, we're going to import a couple of different modules. First, we will require in that HD wallet provider. So I'll call it HD wallet provider. And that's going to come from Truffle HD wallet, HD wallet provider. Next, we will require in Web3. Remember that this is going to be the Web3 constructor, so we've got a capital W here. And then finally, we're also going to import in our interface and our bytecode from our compile script. So we'll get interface and bytecode, and we're going to require that from compile, like so. Notice that we are now in the same directory as the compile file, which is why we're using only the one dot here when we require that file in. All right, now here's the fun part. So the next part, we're going to set up this HD wallet provider. Again, remember, it's going to simultaneously specify which account we want to unlock and use as a source of Ether for deploying our contract. And it's also going to specify what outside API or what outside node we are going to connect to. So we're going to say const provider is new HD wallet provider. And then we're going to pass in two separate arguments. The first argument to this function is going to be our account mnemonic. Remember, the account mnemonic allows us to derive both the public key and the private key. So with the mnemonic alone, we can get total access to our account through this HD wallet provider. Now, hopefully you have written down your mnemonic as we spoke about several videos ago. So I'm going to paste my mnemonic in here. So I'm going to paste it like so. So here's my account mnemonic. If you don't have your mnemonic, if you've completely forgotten it, that is okay. It means you have to go through a little bit of extra effort. If you have lost your mnemonic, then I encourage you to go back to the previous video where we reinstalled MetaMask and donated some coins to that account. So I encourage you to go back there and get a new account. Make sure you write down the mnemonic this time, and make sure you contribute some Ether through the Rinkeby test faucet. The second argument to the HD wallet provider, and I'm going to make sure I put a comma at the very end of the line over here. So there's my comma. The second argument right here is going to be a link or a URL of what network we want to connect to. So this is where we need to specify our Infura link. In this case, we want to attempt to deploy our contract to the Rinkeby test network right here, because that is where we have some number of Ether tokens right now. So I'm going to copy the link right here. I'll flip back over to my code editor, and I'll pass this in as the second argument. Again, please, please, please make sure you get a comma after the account mnemonic on the line above it. So it should be our mnemonic, a comma, and then the link that we want to connect to when we attempt to deploy our contract. And then finally, underneath our provider, we're going to say const web3 is new web3, and we're going to pass the provider in. So this step right here should look a little bit familiar from when we were setting up our tests. This is going to take our provider, it's going to pass it to the web3 constructor, and we're going to get out an instance of web3. Now this instance of web3 right here is completely enabled for the Rinkeby network. We have unlocked an account, so we have a source of Ether, and we have specified what network the web3 instance needs to connect to. So we can use this web3 instance to interact with the test network in any way or shape or form we want. We can use it to send Ether, we can use it to deploy contracts, we can use it to update contracts, whatever we want to do. Let's take a break right here. When we come back in the next video, we're going to use this web3 instance to actually deploy our contract, and we should be able to run our deploy script at that time and see how it's doing. So quick break, and we'll take care of that in the next video. In the last video, we set up our web3 instance along with the HD wallet provider. Now we're on to our very last step, which is to use this instance to actually deploy our contract. Now the first thing I want to talk about regarding deployment of the contract is that our code is going to look remarkably similar to what we did a little bit ago inside of our before each helper of our inbox test file. So we're going to get a list of accounts out of our web3 instance, just like we did before. We'll then create a new instance of our contract by using the web3 contract constructor. We'll call deploy on it and call send on it as well. So essentially almost identical. Now there is one kind of interesting little thing that I'm going to do here. Because we need to make two asynchronous calls. First, we need to do one to attempt to get a list of our accounts that we have access to, and then a second call to create and deploy that contract. We've got two pieces of asynchronous code. Rather than interfacing with those as though they were a promise, I would still like to use the async await syntax. However, we cannot use the await syntax outside of a function, which is what we're doing right now. So we're going to just arbitrarily decide to write a function, and the only reason we're doing this is so we can use the async await syntax. So I'm going to make a function called deploy. I'm going to mark it async, and then immediately after that, we will call deploy. So there is no reason for making this function outside of giving us the ability to use the async await syntax. We could just as easily not write our deployment script inside this function, but then we would not be able to use async await. So again, just a little helper to make our lives a little easier. Now inside this function, we're going to do two steps, exact same steps that we just did inside of our test helper file. We're first going to get a list of all the accounts that have been unlocked through our wallet provider right here. So we'll say const accounts equals await web3.eth.get accounts, like so. Remember that I had said just a moment ago that the mnemonic contains not only our public key but also our private key. But as we saw much earlier when we spoke about mnemonics, a single mnemonic can be used to generate many different accounts. And so the reason that we're getting a list of our accounts right here is that the mnemonic is not specifying just one account, it can be used to generate many accounts. And so we're just going to decide to take the first account out of this list of accounts right here and use that as the basis for deploying our contract. And just to make sure that's really clear, let's add in a console log so we can specify the public key, or excuse me, the address of the account that is deploying the contract. So we'll do a console log with attempting to deploy from account, and then we'll list out the account that is going to be doing the deployment or paying for the deployment. And so I'll say accounts at 0, like so. Then underneath this console log, we can write out our actual contract deployment statement. So this is going to be almost identical to what we just saw a moment ago inside of our test helper. So we'll say await new web3. And notice here that we're using the lowercase web3. This is the instance of web3 that has been configured properly to connect to the Rinkeby network. We're going to access the Ethereum module inside the web3 instance. We'll make a new contract. And into that, we will provide our ABI. Just as before, our ABI is coming into this file as JSON, but we need to pass in an actual JavaScript object. So we're going to use json.parse on the interface. And remember, this interface right here is the ABI. Then on the line after that, we'll say deploy. The deploy statement right here is going to contain the contract's bytecode and any initial arguments that we want to pass to that contract. So we'll say data is bytecode, which we had already required into this file, and then arguments, which is going to be an array that contains all the initial arguments for our contract. So this will be the initial value or the initial message that we want to publish inside of our inbox contract. So I'll say, hi there, why not? And then finally, on the line underneath that, we need to actually send this transaction to the network. So we'll say .send. I'll specify some initial gas to use. We're going to specify 1 million, just as we did before. So I'm going to do 123, 123. And remember, I only put the commas in here just to make sure it's really clear to you. Yeah, I'm definitely doing 1 million gas. So I'm going to delete those commas. And then finally, we'll say which account this is going to be deployed from. So from accounts at 0. We are just assuming that the first account in this list is going to be the account that is used to deploy our contract. All right, now that's just about it. The last thing that I want to do here is wait for the contract to be deployed. And once it is, I want to do one last console log underneath this. And I want to console log out the address that our contract was deployed to on the Rinkeby network. Remember, if we don't record that address, to you and me, it's kind of a mystery as to where our contract just got deployed. We deployed it somewhere, but we don't know where it got deployed to. So we need to at least print out or somehow record the address that our contract ended up at. So we're going to assign the result to this right here to, how about just a variable called result? I think that's simple enough. So result is going to be an instance of our contract, and underneath that, we'll just console log out the address. So I'll say something like contract deployed to, and then the actual address, which you will recall is available on result.options.address, like so. All right, so we wrote a pretty good amount of code in this video. Let's finish up by deploying our contract. It does take some amount of time to deploy, so I think we can deploy it right now and then continue in the next video and just kind of observe what happened and also look at some interesting things about the deployment process. So back at my terminal over here, I'm going to run node deploy.js. And we'll see if we made a mistake or need to fix any typos or anything like that. So it's definitely going to take a moment to start up because we have to wait for that initial compilation. All right, so here we go. I see attempting to deploy from account so-and-so, And then like I said, it's going to take a little bit of time for this to actually be deployed. Remember, we are now on the Rinkeby test network, and it takes some amount of time for these transactions to occur. So let's pause the video right now. We're going to come back to the next video, and we're going to see what happens after we wait a significant amount of time. So I'll catch you in just a minute. At the end of the last video, we attempted to deploy our contract. Hopefully you saw a message like this appear on the screen. So something that says contract deployed to something. This right here is the address of our deployed contract. So this is where it exists on the Rinkeby test network now. At this point, you might be saying, okay, well, that's great. We deployed it to Rinkeby. What good is that to us? Well, in an ideal world, if we had some idea of how to interface with these contracts from a web application, we could then build some HTML application or HTML, JavaScript, CSS application that could somehow interact with this contract. And that's exactly what we're going to do starting in the next section. So we don't quite have those skills just yet, but we're going to start to write another contract. We're going to deploy it in the same fashion, and then we'll learn how to interact with these contracts from a normal web page. But before we do, there are two kind of interesting things I want to show you. Two things that are kind of fun, at least I think, to interact with your contract and get a sense of what just happened. I'm going to open up my web browser, and I'm going to show you a little tool that's a lot of fun to work with to kind of take a look at your contract and see what it's doing on the actual Rinkeby network. So in my browser, I'm going to navigate to rinkeby.etherscan.io. And of course, I'm going to put this nice and large for you to read. There we go. So rinkeby.etherscan.io. Etherscan is a website that reads all transactions that flow into the Rinkeby network, the main network, the Kovan network, and the Ropsten networks. It reads in all these transactions and records them here for you to see on an easy to view web page. Up at the very top right hand side, you'll see a search box. So this allows us to look at any account address that belongs to the Rinkeby network, any transaction, or any block number that has been committed. So we can use this tool to not only look at our accounts as they exist on Rinkeby, but we can also look at our deployed contract as well. This web page, Etherscan, can be used with any of these accounts, or excuse me, with any of our networks. So right now we are connected to Rinkeby, but if we wanted to flip on over to the main network, we could go just as easily to www.etherscan.io. And then we should see at the very top, well, somewhere on here, essentially this is the page for the main network. I think in this case it doesn't actually specify that this is the main network, but it is. So let's go back over to Rinkeby, and then I'm going to go and grab our address for our contract from the terminal. So here's my address. I'll copy it, and then I'm going to paste it into the search bar at the top right hand side. And do make sure that you are on the Rinkeby test network here. We can click go, and then it will show us some details about our newly deployed contract. So you can see very simply right here, here is the transaction that was used to deploy the contract. Here's what block number it was included into. Here's the age of the contract, and here's the person or the address or the account that was used to deploy it. Over time, if we start to modify our contract in some fashion by using some other tool, we can come back here and see a list of other transactions that have been sent to this contract. And we can look at those transactions and get a better idea of what they're doing. We can also take a look at some details about this contract itself on the tab Contract Code. Over here, you can get a glance at the actual bytecode that is used for this contract. So yes, the code for your contract is essentially publicly available. Now, whether or not you can divine a lot of meaning from this bytecode right here is kind of up to you, but certainly there are tools to kind of deobfuscate what's going on. And if you want to, you can even click on this button right here that says Switch to Opcodes View, and this puts it into a much more readable format that can at least give you some idea of what the contract does. So again, I just wanted to show you this tool because it's a great little thing to just get a better idea of what's going on with the Rinkeby network and see exactly who is interacting with your contracts. Now at this point, like I said, in the ideal world, we would have some type of web application that we could use to interact with our contract. But before we go that far, there's one other way that we can interact with our contract as it has been deployed to Rinkeby right now. So let's continue the next video, and I'm going to show you that tool that we can use to interact with our newly deployed contract. So quick break, and we'll tackle that in the next video. It feels like kind of a letdown to deploy our contract to Rinkeby, but then not really be able to interact with it in a meaningful way. So in this video, I'm going to show you a very easy way that you can interact with your contracts immediately after deploying them without having to make some fancy web front end or anything like that. So the first thing I'm going to do is to grab my contract address right here. I'm going to copy it, and then I'm going to flip on over to my browser. I'm then going to open up the Remix tool again. If you have closed Remix, remember you can get to it at remix.ethereum.org. Now when you first load Remix back up, it should be auto-saving the contract that we had been working on, but if it did not automatically save the inbox contract, then you can always flip back over to your code editor, open up our contract file, copy all this, and put it back into Remix. So make sure that you do have your contract in here because that is important for the next step that we're going to use. All right, I'm going to flip on over to the Run tab right here. We've been using Remix up to this point to run our code on a test local network that exists only inside the browser. However, Remix can also be used to connect to actual Ethereum networks and interact with deployed contracts. So up at the top right-hand side up here, you'll see Environment. We're going to want to open up this dropdown and select Injected Web 3. Injected Web 3 is an instance of Web 3 that has been injected into this web page by the MetaMask extension. So this is a version of Web 3 that has already been configured to not only connect to the Rinkeby test network, but it also has direct access to all of our accounts. So the accounts that have been logged into or have been authorized inside of MetaMask. We can then verify that this is successfully connected to MetaMask by selecting our account from this account dropdown right here. So this is definitely my account, CF0, and it has 21 Ether, and I can verify that inside of MetaMask right here. So CF0, and I have 21 Ether. So this is definitely it. Now that we have selected the Rinkeby network and our account, we can interact with our deployed contract directly from Remix. So yes, it is an awesome tool. I love Remix personally. You can do a lot of neat things with it. To interact with our deployed version of this contract, rather than using the create button right here, we are going to paste in our address that we got from the terminal. So this is the address for my deployed contract that we just deployed back here. So it's this address right here. I can then click on @address right here, and that will give us a handle on our deployed instance of the contract. So this is our deployed inbox contract right here, and we can interact with it just the same way that we were before by clicking on these buttons. Now before, when we were interacting with our contract, you will recall that any time we wanted to write some data to our inbox contract, it was an instantaneous process. So we were able to set a new message in there. We could add a new message and then click on the button and poof, instantly we got a new message set. But remember that very long video that we watched, we went through a long time ago, where I'd said that on real networks, it takes around 15 to 30 seconds to actually get confirmation of changes to our data. And so now that we're not using this local test network in the browser, anytime we want to change data tied to our contract, because remember, anytime we are changing data inside of a contract, we have to send a transaction. It takes some amount of time to be processed. So now that we are working with our real contract, we have to wait a long time for our message to be updated because we really are sending a transaction to the network that is targeting our contract and attempting to modify that contract's data. So we can very easily see this in action. When we click on message right here, that is a call. And calls are instantaneous. So we very quickly get a response back that says the current value is hi there. And we can see some details about that transaction in the log, or excuse me, that call here inside the log. However, if we add a new message to this thing, so I'll say bye, and then click set message. So this is interesting, isn't it? So this is the first time we've seen this window right here. we are now attempting to submit a transaction to the Rinkeby test network to modify some data that exists in a contract. Remember, that is an operation that costs money. So we are spending Ether just to update the data inside of our contract. Whenever we attempt to send some money through one of our accounts tied to MetaMask, we get this MetaMask notification. And it says, hey, the current web page that you are on is attempting to use some money out of your account. So in this case, it says that our account 1 with this address and this much Ether is attempting to send some amount of Ether over to this target address over here. And this is the address of our deployed contract. In this case, updating the set message property right here is going to cost about 0.0003 Ether, or about 26 cents. So we have to actually submit this transaction. We have to confirm this transaction in order to update some data tied to our contract. I'm going to click submit, and then we're going to have to wait those 30 seconds or so to eventually get receipt of the transaction. And something that says, hey, yep, this has been included in the blockchain. We now have a new value for set message. So at this point, we can click message right here, and you're going to notice that it still says hi there. Now I just got a little pop-up over here. This is the receipt of the update for the message property. So if I click on message now, I will see that value update over to buy. And so in action, this is a great example of how we have to wait some amount of time to write data to our contract, and also how we have to spend some money just to update any data related to our contract. All right, so this has been, I'm really happy with this example because I feel like it really brings all these topics full circle and gives you a good sense of how MetaMask, it ties in, and the differences between calling a function versus sending a transaction to a function, how we have to wait for data to be persisted to the blockchain, and just all that kind of stuff. So I feel like this has been a good review on many topics, but we've covered so much content in this last section around setting up this application that I want to continue in the next video and do a quick review on some of the big highlights of what we've achieved so far. So let's take care of that review in the next video. In this video, we're going to review some of the big highlights of what we just accomplished inside of our project. I first want to discuss some of the differences between the Remix editor that we were just using and writing our contract in our code editor. When we first wrote out our inbox contract over here, the Remix editor seemed like a great place to author an Ethereum contract. We were able to get some auto completion when we wrote code in here. We could then immediately test the contract, and it just seemed like it was a really handy place to develop the contract. So why exactly did we decide to write the inbox contract over here in the code editor? Well, in reality, in a real project where you start using Ethereum, it usually ends up being the case that you write the contract rather quickly, and then you spend a tremendous amount of time working on the front end application that is meant to interact with that contract. So as nice as Remix is, usually we might end up using Remix at the very start of a project to kind of work with and tweak a contract. But then eventually we end up inside of our code editor because the vast majority of work that we usually have to do is around writing tests for the contract and writing the front end application. In addition, as nice as Remix is, it doesn't have built-in support for Git or GitHub or Bitbucket or any type of version control. And so if you expect to be working on a project with many other people, well, chances are you're going to want to use some type of version control so you can easily share the source code of your contract. And again, that's going to happen easiest when you're writing your contract inside of a code editor. After we installed our code editor, or after we got our project running inside of here, we then started working on our compile script. So here's our compile.js file. Inside of compile.js, we used the Solidity compiler. We then read in the contents of our inbox contract and fed that directly into the compiler right here. Recall that the compiler is really built for compiling multiple contracts or multiple files at the same time. So the output that we got back from this compile operation had a couple of different contracts associated with it, or at least the ability to read in multiple contracts. In this case, we only cared about our inbox contract, which is why we returned from this file :inbox right here. In case you're curious why we have :inbox, what is the colon doing here? Well, if we had multiple files, each of which contained different contracts, in front of the colon would be the file name that the contract source came from. So for example, if we just fed in, rather than the raw text of our contract right here, if we fed in a path to a couple of different files, and maybe our inbox contract was in a file called like inbox contract, then we would have had to access inbox contract right here. So again, this would usually be used to specify the file name. But in this case, we only fed in the direct source code, so we didn't have to worry about that. After finishing up our compilation script, we then started working on some tests. Inside the test file, we had a lot of different stuff going on. And so I just want to remind you about the purpose of some of these different libraries that we used. First off, we made use of Web3. This is our portal to the Ethereum world. It's how we retrieve information from the network, and it's how we make changes to the network as well. The Web3 library always has to be given a provider. The provider instructs Web3 what network it is connecting to, and it also contains some information about the different accounts that are available to Web3. In this case, our provider was given to us by the Ganache CLI module. Ganache hosts a local test network. So just like we had a tiny, very small network running inside of the browser with Remix, Ganache is doing the same thing. So Ganache automatically generates some number of accounts. We can send transactions to this network. We can deploy contracts to this network. It really is a tiny little test network. The important thing to remember about Ganache is that it always automatically completes or processes transactions almost instantaneously. And that's why we like to use Ganache inside of any test-related code like we did right here, because we want our tests to run as fast as possible in general. Inside this test file, we also imported two important things from our compile file, both the interface and bytecode. Remember that the interface right here is our ABI. It is the translation layer that communicates data from the network over to the JavaScript world. And the bytecode was our compiled contract. We then used Mocha to set up a testing harness. We defined a before each function that automatically got a list of all of our available accounts, and then deployed a new instance of our contract to the Ganache local network. The important thing to keep in mind about this before each right here is that it is executed before every one of our tests. And that's really important. We want to make sure that as we start writing tests, we are always working with a fresh copy of our contract. If we write a test where we start to modify a contract or even delete a contract, then we want to make sure that those changes don't boil over to the next test that gets executed. We always want to be working with a fresh one. Inside of our describe block right here, we provided a couple of different it statements, each of which was meant to test a different aspect of the contract. Inside of each it statement, we were able to access the contract directly and then get access to some of the different functions that belong to that contract by accessing this methods object right here. Remember that the methods object contains all the different functions that belong to the contract. So in our case, we had a message function and a set message function, and we were able to get access to both those from the methods object. The other thing that was kind of awkward about this methods object is that whenever we accessed a function on it, we had to do kind of like two sets of calls. We had to first reference the function we wanted to call, and in this first set of parentheses, we provide any arguments that need to go directly to the function in the contract. After that, we then specified either call or send. Call is used anytime that we want to call a function. And remember, calling a function is a read-only instantaneous operation. When we send, that means we want to make a change to the data that exists inside of our contract. When we send, it is not an instantaneous operation, and we have to wait a pretty significant amount of time for a send operation to be completed. We also have to specify exactly who is going to pay for that transaction as well. Now, of course, on our local Ganache network, any send operation gets processed instantly. So we didn't actually have to wait very long for it to be completed, but in theory, in the real world, we would have to wait anywhere from, say, 15 to 30 seconds or so. So that was our testing file. Now, the last thing I want to go over, and I know we just wrote this, so it might seem like premature review, but hey, what the heck, let's go over it, our deploy script here. The second half of the deploy script looked very similar to what we just went over inside of our test file. So we used Web3 to get a list of our accounts and then deployed our contract. However, it's what went on the first half of this file that was really interesting. We used a module called HD Wallet Provider. The purpose of this module right here is to both connect to some target network and unlock an account for use on that network. In this case, we unlocked account by using our 12-word account mnemonic right here. By providing just this mnemonic, we are able to unlock and generate the public key, private key, and address of our account. We specified that our provider should connect to an Infura node. Remember, anytime that we want to connect to a real network and not one that is just hosted locally on our machine, we have to connect to a real node. You'll see a lot of documentation out there that advises you to use modules like, say, Geth or Parity on your local machine to connect to the Ethereum network. However, setting those modules up is a real pain in the rear. So wherever possible, I really recommend making use of Infura because it is a free service that is rather easy and straightforward to use and doesn't require you to host really expensive nodes on your local machine. After setting up this provider, we then fed that provider to our Web3 instance, and then we had a copy of Web3 right here that was pre-configured to connect to the Rinkeby network and had already unlocked one of our accounts, which had some Ether and could be used to deploy our contract. Ooh, all right, so that's a lot of knowledge. We went over a lot of stuff, but I can guarantee you one thing, we are not done yet. So we still have a tremendous amount to learn about Ethereum. We're gonna pause here. We're gonna start working on our next project in the next video. So I'll see you over there.